Welcome to our chief guest, Mr. Rajendra Petkar, Chief Technology Officer from Tata Motors, for his precious time. I'm equally honored to welcome other industry dignitaries, friends, to participate in this event, and I'm sure they will have a lot of interactions during the day today. I'm happy and excited to share a platform with many FEV experts who are speakers today, and they will talk about different vehicle technology options and scenarios for global and Indian market for this. This event is very special. We never had an event in the last 2 years because of COVID, and I believe that this event is a kind of curtain raiser or door opener, and we will have many more interesting events in the next months of this year. Before handing over the session to my technical team, I want to draw your attention on a few facts. So whatever the event we are doing today, this is following FEV vision, where we are committed to build global partnership to develop sustainable energy and mobility solutions. We are going to talk about battery safety today. We are going to talk about different vehicle concept and different vehicle technologies which is in line with our offerings for the mobility solutions. FEV is predominantly known as a powertrain engineering supplier. People talk about that we are one of the best organizations for the ICE engine, for the alternate fuels, also for the electric powertrain like battery, motor, inverter, converter, all the control algorithms around all these e-mobility systems and so on. Trust me, we are equally strong, equally capable, equally competent, equally experienced into the vehicle design and development areas. Thanks to our Egyptian partner who allowed to show this slide here, where we are developing first electric car for the Egyptian market, and we are doing the complete electrical vehicle development for them. India has been a big focus for FEV always, not only in terms of business partnership with the automotive players, but also to develop a very strong, competent, and big technology center for this. And if you look today, we are serving our clients, our partners in India and globally into vehicle engineering, into electric mobility, into smart mobility, into conventional powertrain, and so on. We are close to 800 engineers working from India Center. Could you imagine that 10% of FEV strength is working from India location? Globally, we are almost 7,000 experts working across 43 locations. So 10% of the experts are working at India locations, supporting the local requirements as well as the global requirement. We have quite a nice spread all over India. So we have 3 centers in Pune, our technical center in Talegaon for testing, validation, calibration, our vehicle engineering center at Auto Cluster, and our smart mobility center at Baner. We have a center in Chennai for embedded software. We have a center in Delhi for our project supports. And soon we are starting 2 more centers, one in Bangalore and another in Jaipur, to extend our offerings into different areas of software engineering. FEV is one of the pioneers to offer end-to-end solutions for the automotive industry. And here you can see some of the mega trends where FEV is very strong, and they are supporting multiple projects in these areas. So hydrogen economy, either in terms of hydrogen combustion engine or fuel cell electric powertrain, or the entire battery electric vehicle, or smart mobility concept like a car sharing, or different software topics in terms of e-architecture or ADAS, connectivity, and different topics and so on. So one side, FEV can offer all these technology solutions supporting the mega trends, and other side, we have a strong know-how of the vehicle engineering. So we are like a one-stop solutions where we know that what is the best marriage and what is the best integration between these technology solutions and our vehicle engineering offerings. India is not far away in electrification. If you talk about the two-wheeler and three-wheeler, I think we could see that every coming day, now this transformation is becoming faster and faster. So for the three-wheeler, already in the last month, we sold more electric three-wheeler than the conventional IC engine three-wheeler. Two-wheeler is also transforming quite fast. I believe passenger segment and the light-duty segment is also not far behind. If you look at this slide here, where we combinedly mentioned the passenger or all the vehicle below 3.5 ton, whether passenger or the light commercial vehicle. So one side, you could see that Indian market is growing. So we expect around 5.7 million vehicle sales every year by 2030. And out of that, 25 to 30% will be electrified. And trust me, if we would have talked earlier, year before, it was lesser. And I'm sure if we'll talk the year later, even this percentage could be higher. So every day, now situation is becoming more and more favorable in the direction of the electrification. We have to accept this trust that the passenger market is getting electrified sooner than ever. Now, we are going to discuss all these topics in today. So we have Mr. Rajendra Petkar with us, who will give his views on the automotive industry. We have many FEV experts who will talk about different topics on the vehicle technology and the safety aspects, like Alex will talk about the automotive technology and the future trends. We will talk about the architecture and integration for the electric vehicle, importance of the simulation for the electric vehicle, and we are going to present a very interesting case study of ICE to BEV conversion. Of course, safety is always very important for the future transportation requirements, either in terms of thermal management or in terms of the battery design and all the safety aspects. The E architecture now, everybody is talking that software will define the future releases of the vehicle, and we have interesting topic today to present the software-defined vehicle and FEV experience into this area. And the last but not least, together with our Egyptian friend, we will also share the project which we are working on, the electric vehicle and so on. So I'm pretty sure that today is going to be very excited. Let's make this interesting together. I don't want to become now barrier between the technical presentations and you, so I can announce the start of the Vehicle Technology Day. Thank you for your kind listening.
Thank you so much, Mr. Vijay Sharma, for your inspiring words. Good morning, everyone. I am Dr. Rajni Sharma. Once again, welcome you all. So friends, without any further delay, let's begin the day proceedings with the lighting of the inaugural lamp, which is symbolic of knowledge. This will be accompanied by the recital of Ganesh Mantra for auspicious beginnings. Om Tamaso Ma Jyotirgamaya, lead us from darkness to light. Let us commence the day with prayers to the Almighty for removal of darkness. May He illuminate us with enlightenment. I request the following dignitaries to approach the dais as their names are called out. Please join me in welcoming our chief guest, Mr. Rajendra Petkar, Chief Technology Officer from Tata Motors. A louder round of applause, ladies and gentlemen, to welcome FEV's vehicle man, Mr. Michael Hogg, Global Vice President, Vehicle Development, FEV Group. Please put your hands together to welcome Mr. Alexander Nase, Managing Director, FEV Consulting, who is coming to us all the way from Germany. Put your hands together to welcome Mr. Bernd Kischer, General Manager, Vehicle Development, FEV Group. And lastly, please welcome our own Mr. Vijay Sharma, Managing Director, FEV Group, India.
गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि.
Thank you so much, everyone. May I now request you all to kindly take your seat. I hope that the light from this spiritual lamp will ignite our intellect to create better vehicle technology. Now, I would like to invite our chief guest, Mr. Rajendra Petkar, Chief Technology Officer from Tata Motors, to share his views on Indian automotive industry and ways forward. Mr. Rajendra Petkar, Chief Technology Officer, Tata Motors, is responsible for leading the product development and engineering function at Tata Motors. That involves design and development of a vast range of vehicles and components for the TML product portfolio. With a career spanning over 28 years of automotive research and development, he has held key positions and led critical projects at Tata Motors ERC. He holds many patents and research papers to his credit. So I request, sir, to please join us.
Mr. Vijay Sharma, Managing Director, FEV India, Mr. Alexander Nase, MD, FEV Consulting, Mr. Michael Hawk, other experts who have all the way traveled from Germany, the eminent speakers from FEV, ladies and gentlemen, my colleague from the industry and various institutes who have gathered here this morning for this program. A warm greetings to you. Good morning, and let me just say that after almost a period of 2 years of working in silos, there is nothing like better than coming together in the physical form and spending a day like this, and that too on a topic related to the technology. And I'm particularly very much passionate about the new technologies, the new areas which actually are shaping the growth and the development of the automotive industry. At the outset, I would also like to compliment the FEV team for hosting this kind of an event, that too in Pune. And I can see here that I think most of the colleagues are from Pune. I think this is a great benefit to the automotive industry, which is based here in the Pune location. If I really take a view, if I take a helicopter view of what's happening, and especially in the last, say, 2 to 4 years, though actually the innovation got accelerated in the last 2 years, but there are clearly some global trends which we are seeing, which are going to actually shape the complete industry landscape. And then I'll come to the automotive side shortly, how it's impacting the automotive sector. So any part of the industry, whether it's a transport sector, whether it's a telecom sector, whether it is a energy sector, or it's a logistics sector, I think you name it. It has been a time where the innovations are actually at its peak. One of the finest example, if I were to take, is about the pharmaceutical industry in the last 2 years, that the development of a vaccine, the COVID vaccine, is something as an outstanding example of the innovations which have happened across many geographies, and not just the innovation in terms of a development of a vaccine of an unknown, let's say the COVID kind of a virus, but also about the innovation in terms of the logistics, the distribution, the online connect with the people, development of a portal, and making sure that the vaccine actually reaches to the last person on the ground. So this is something, it's a tribute to all the community, which is involved in the development and the creation of knowledge. So this is one global megatrend that I see, that the development of new technologies, the innovation, which is something which is happening all over. The second global trend that I am clearly seeing is about the emergence of a geopolitical situation which is leading to the rise of a protective state. And what do I mean by that? With the outbreak of a COVID in the early part of a 2020, I would say most of the countries, they had shut down their boundaries. And therefore, one, because of the fear of a transmission of a virus, but also at the same time that the countries became highly protective in the manner, they wanted to actually conserve the resources within their territories. Now, add to that, if we see what has happened in the Indian context, with the region in the northeast side, under the threat of the external aggression, so that is something which created a sort of a situation which made India to think whether our policies are right in terms of being so open to the external world. And in the recent past, with the war that has broken out in Europe between Ukraine and Russia, I think has further reinforced this belief that the countries across the world are actually, wanting to protect their own economies, and therefore it has the profound impact on the way the trade is happening in terms of, the barriers which are getting created. And the countries would like to become the self-reliant. You can just see what's happening in the energy sector, especially with the cutting off of the gas supply from Russia to the other parts of the Europe. So this is the second global mega trend, which is about the rise of a protective state. The third one, which is actually driven by the concern on the global climate change. And what happened in the COP26 toward the end of the last year, where the commitment that has been made by almost all the countries that as to when they would like to become the net zero. So take the case of India, we said 2070, take the case of China, it said 2060, take the case of America, it's 2050. And these are actually the very tough tasks considering where we are today. And this is purely driven by the fact that, when you look at the rise in the Earth's atmospheric temperature, which is continuously rising, there is a need to actually cap it to below 2 degrees centigrade. So for all the right reasons, very valid reasons, it's for the safety of the human beings, the safety of flora and fauna across the world on this earth is something which is important. And therefore, that's driving the strategies of the various countries, various industries. And in the journey toward the net zero, you will see that a lot of innovations are going to happen in the area of how we actually utilize the energy, and which are those the less polluting or the zero emission emitting technologies which will actually come to the fore. The demographic and the social change is something which is the next global mega trend. And when I'm mentioning that, I think the reason for mentioning it here is because if you look at the rise in the population in the world, almost more than 97% population increase is happening in the Asian or the ASEAN region. And therefore, the center of gravity of the economy is actually shifting towards this region, thereby making this region quite attractive in terms of the growth and the knowledge, and also in terms of the innovation and the impact that they will eventually have on the world economy. So this is actually shaping the various industries. Automotive industry is not an exception. And take an example of the component industry, which is actually willy-nilly shifting their bases to the Asian and the ASEAN region as we speak. And the last but the not least is about the rapid urbanization. And though we keep saying that there has to be equitable distribution of the wealth between the rural and the urban economies, but all said and done, there is a polarization which is happening toward the urban regions, and the continuous flow of the people which is happening from the rural to the urban side actually is making the city planners to think that what is the concept of something called as the smart cities. And this is ever-growing debate. And but I must say that we are not in the midst of that, but we are in the very early part of planning the cities which are going to be the smart cities in the true sense. And for me, the definition of the smart city is not just about tech savvy, but it is also about the mindset of the people that we all should perceive that we have become smart in every aspect. So therefore, if these are the 5 global megatrends that I'm seeing, say, let's say from the helicopter view. Now come to the India, and therefore, what does it mean when it comes to India and how we are, participating in this overall journey? So in the month of March 2022, India became the 5th largest economy in the world, surpassing Britain. And that's something quite significant. And I think, what's being said is that we are poised to become number 3 in the world by 2030. And yesterday only I was seeing on the television channel, what was being said is that despite this doom and gloom about the inflation rise which is happening, in Americas, in Europe, and in the other parts of the world, of course, India is not an exception, but the trajectory of the inflation increase in India is much lower. And India is actually emerging as the strongest, the growth economy in the whole of the world. And it's not just yesterday that I have heard this. I have been hearing this almost for the last 6 to 8 months. So this is something which we need to take a note of when we talk about, India poised to become the 3rd economy in the world. It's going to happen. There is a lot of focus on the infrastructure development, and this is especially for the colleagues who have come from overseas, from FEV, that, be it the infrastructure side where there is the road development, which is happening all over the place. And, we have one of the dynamic, the ministers, who is personally driving the agenda to create the road network across the country. So the focus now, having got the traction on how to build the nationwide, the good roads to actually improvise the logistic cost. Now the focus also has been shifting towards making use of the waterways. So this is something which is now going to happen. The third thing that I want to talk here is about the rapid digitalization. And, if you look at the situation about a couple of years back to now, there are already now 600 million people who are making the use of a digital platform in terms of their daily activities. And this is also continuously rising. And eventually, this has also created a number of the startup companies. Last but not the least, I think the focus by the government of India, and the government is quite active in many areas. They are very aggressive. They are pushing all of us. We have witnessed what they can do as far as the automotive sector is concerned, but we are not the exception. In many other areas, they have been actually pushing the industries to do much better. They have, have a number of platforms like Janadhan Yojana, Ayushman Bharat, Atmanirbhar Bharat, Vocal for Local. These are all the strong initiatives which the government has taken, which is actually helping to shape the way the industries are going to perform in the time to come. So from the global to the local now, if you come to the automotive sector, I think there are a few areas which I thought I must highlight and which would become quite relevant for the today's discussions also, is about the continuous focus on those in the automotive side. We used to say the global megatrends like ACES, autonomous, shared, electrified, and the connected mobility. I think those would be there. To me, it's almost like now the daily routine for us. Nothing special about it. Now we are riding on that wave. And many of the automotive companies in India, they're actually delivering the products which actually speak of, embodiment of all this philosophy related to the ACES. So let me not spend much time as far as that particular theme is concerned, but also the focus by the industry in terms of the efficiency improvement, in terms of making use of the renewables, that's which is on the rise. As an example, if we talk about the renewables, this ethanol is a great story. From nowhere it emerged as a sort of as a strong requirement and the push coming from the government. And when there is a policy level intervention like that, then the entire industry, I mean, not just the automotive industry, but look at the food industry, look at the sugar industry, look at the finance institutes. I think all of them have come together to make it happen. So 20% ethanol blend in the gasoline is something which is now poised to happen come next April 2023, and 10% is already there. So this is the kind of a focus which is there as far as the renewables are concerned. The focus will continue to be on the advanced material science, the industry 4.0 for the manufacturing transformation. And there is a pivotal shift which has already happened. And I think today that's going to be discussed in the papers presentations. The pivotal shift which has happened from the hardware to the software. I mean, this industry about say 15 years back, and I'm talking here about India, was much of an hardware driven, but with the advent of the advanced regulations, and especially here I'm talking about the emission regulations, in 2005, there is an increased use of the sensors and the actuators. It started with the engines, then the transmissions, then after treatment, then the cockpit, and you name it now, in almost all the areas, the aggregates and the modules on the vehicles, there is the significant penetration of the electronification which has happened. So now this actually means that no more this is now the piece of a hardware, but it's actually the computer on the wheel, and there's a sky limit as far as what can be done as far as the shift toward the software-driven vehicle culture is concerned. And last but not the least, about the cloud computing solutions, which will be driving the whole backend processes, the backend infrastructure creation, which will support not just the new form of the connectivity, which will come up thanks to the 5G, and in the future about 6G. So all of this is something which is the play in which the transport sector and the automotive industry per se is going to work on. So, I mean, if this is what it is at the overall level, I think we are in the best times. We are in the much exciting times. I think you name it, with the innovation coming across into all the areas of the value chain, I think the sky is the limit. So therefore, I think if I look at today's the agenda, I think the topics are very, very relevant. They're all towards all the modernity that is going to come in the vehicle systems, in the vehicle architecture, from the usage point of view. However, what I would like to insist here, that what must not change is the kind of an experience the consumer must get. I mean, the technology, whether it is the hardware or the software, is something which is, yes, it's sitting in the car or the 2 or 3 wheeler or in the commercial vehicle. But actually, at the end of the day, what matters is an experience the consumer gets. And he or she pays for the consumer experience. So let's focus on that part. While yes, we are all going to be passionate about the innovations in the hardware and the software. So this is one thing that I would like to insist on. Secondly, while today's agenda is heavily loaded or skewed toward the electrification, but there are many facets of the electrification. Also, the emergence of the hydrogen, especially the green hydrogen, and what can be done and how it can be leveraged. I think it becomes another tech day, if I may say so, where I think all the industry members would be interested in. We should try to see whether it can be done, picking up that as a theme. So with some of these of my thoughts, I would like to just conclude by wishing all the best for today's program. I would also like to appreciate the growth that the FEV India has had, and it started in 2006. I know barely a handful number of people, but today it was heartening to note that it's more than 800 people on the role of FEV India. So this is a phenomenal growth, and my congratulations and compliments to the entire FEV team for this growth and supporting the industry in India. So with that, thank you very much for inviting me here, and it has been my honor to deliver the keynote speech. Thank you.
Thank you so much, Mr. Rajendra Petkar, for sharing your valuable outlook on Indian automotive industry. And we'll definitely come up with more tech days on hydrogen and technology you have mentioned. So now, I would like to invite Mr. Alexander Nasse, Managing Director at FEV Consulting Group and alumnus of Harvard Business School. He is an established management consultant with extensive experience in the automotive and aerospace industry. He is going to enlighten us on automotive technology and future market trends.
Thank you so much for the kind introduction, and it's really a big honor for me to be here today with you, having a chance to present our views on automotive trends. And I think it's wonderful to connect to the talk we have just heard before about innovating to zero, our ambitions and the global view you gave on your trends and your vision on India. And I will now try to put some of your words also in some pictures and some graphics, and I think it will nicely connect to what we have heard just from Mr. Petka. So my talk is about innovating to zero. What are the new automotive technologies and what are future market trends? I'm responsible for the FEV consulting business. It's a separate business unit within the FEV. And I've started that business within FEV more than 10 years ago, in 2011. And meanwhile, we are 120 people. And our aim is to connect the deep technology know-how of our colleagues from the different business units and bring a strategy and technology consulting flavor into our work. So we see ourselves as a hybrid consultancy connecting strategy and technology. But let's start with a bird's eye view on the business models that will change and evolve and the mega trends. So what we have heard also today is that the ecosystem is changing, and we will see an additional business model evolving to the very old known vertical business model of the pyramid structure, the OEM driving the suppliers, defining the products and being very much hardware focused. And in addition to this business model, which is known and we all live in this world, we now see a horizontal business model emerging, and it's already there, where we now need to focus also on partnering with other industries, having good relationships, alliances, and creating new services and mobility solutions that go far beyond the hardware. And I think this is putting also some additional stress and complexity to the OEMs and to the tier one suppliers, figuring out whom to work with, what is the right alliance, where do I play, where do I basically partner with other industries. So I think this is something that we deeply discuss with our customers. And if you are interested to continue this discussion, feel free to approach me also in the coffee break. I'm happy to go on that. So yeah, some of the questions is, how do we collaborate? Do you have any white spots in these new business models? Do you have a good understanding of the new players that are outside of your known industry, but you need to connect to them, energy providers, software companies, insurance companies, and how do they disrupt and attack you maybe in the future? And I always say, keep your enemy close. If you can't fight them, make them your partner and alliance. And then also it's about adapting and enhancing your product offering from the hardware more towards the software and the services. And last but not least, and I think there FEV is also your trusted partner, do you have the right and sufficient capabilities to also fulfill all these tasks in the new business models? Are you able to manage your extended R&D enterprise? Moving away from the business models, and today I'm not only talking about CASE, which I think is known to everybody, so connected, automated, shared, and electrified. We actually put an additional S to it because we think the second S, the sustainability, is now becoming more and more important. We cannot only talk about technology, but we also have to talk about a sustainable technology. And now join me in very quickly go through a journey of all these 5 big mega trends for the automotive industry. And hope you will get some more inspiration and knowledge that we can share together. So starting with the C, connected and the software-defined vehicle. We already heard about that big mega trend. So connectivity means connected to everything. So the vehicle is becoming part of a much larger ecosystem. This is why this vertical business model is changing to a horizontal business model. And we need to understand how to connect the vehicle. And it's becoming part of what we also heard, the smart city of the future. Yeah? Being not only a device that is traveling in the roads, but can also add value to the city, to the communities with all those technologies. Yeah? And there we have, of course, the communication technology that is relevant, which is on the one side the direct communication between vehicle and vehicle or vehicle and infrastructure, but there's also the connectivity through the mobile broadband. Yeah, and the connectivity in the automotive, we see on the one side that the automotive industry is now connecting towards the telecom industry. So you need to work together. You need to define also the standards for the future. You need to define the services and creating those partnerships. And we heard about 5G. 5G is a key enabler for the next generations of automated vehicles, for the data flow between the vehicle and the backend, the clouds. And last but not least, we will see that the direct communication to reduce and innovating to zero just not only means innovating to zero emission, but also innovating to zero accidents. And the direct communication can also have a huge impact on that, vehicles talking to each other, being able to do that. I just saw on the newspaper that also you in India are now about to roll out the 5G. So I think this is a major step towards this connectivity bit. So you're basically on the way to implement that technology. But as we also have heard, 5G is now being implemented, but technology is developing. Yeah? Every 10 years we see basically a new generation, and 6G is just around the corner. So by 2030 we are expecting that 5G will also come into the market. And what does this mean? What is the difference between 5G and 6G? Here we are talking about peak data rates of 1 terabits. We talk about a significant decrease of the latency. And this is a key enabler for the further development of automated vehicles, yeah, that we have this latency. Plus, when we talk about the Internet of Things, the huge number of sensors that we are connecting, we need to have the 6G, that we have this connection density, this 10 million devices per square kilometer possible to connect via 6G. So there is a huge step again from 5G to 6G that we will see, and it will have a huge impact also with regards to the network reliability, which is also a very deciding factor for having this automated vehicles on the road. Yeah, and last but not least, on the connectivity and software-defined vehicle, we heard it. We are moving away from the conventional vehicle design, but talking about the mobile phone on wheels or the software-defined vehicle, and change a complete mind shift that we will see here, how vehicles are being developed and defined. And for that, we need to change also the EE architecture, and I think we will hear more about this today. So from the past, where we had this distributed architecture, where we just adding some ECUs to the vehicle, yeah, going beyond the 100s of ECUs in the vehicle, almost impossible to manage and integrate, and they are not really working and talking to each other. We need to come to a more centralized EE architecture, and this is what we are pushing forward, where we are developing the services and build up the know-how, and I think this is a way we will see very soon. Yeah. So all the new EE developments we are doing, they are moving more towards now the domain centralized EE architecture and then the vehicle centralized architecture. Yeah, but it's not only the technology, it's not only the architecture itself, but it's actually how does the organization do this? Yeah? What kind of processes are needed? What needs to be changed? How do I set up my organization? And what kind of software competences do I need to build up? And here we are also supporting a number of OEMs around the globe to overcome these hurdles, to understand, what do I need to do differently, moving away from a pure V development cycle into more agile development processes, what are the right tool chains, but how do I enable my organization for this, So this is a big topic, and we will learn more about FEV-IO, a newly formed entity within the FEV group, and together with our colleagues from FEV-IO, FEV Consulting is advising many of our customers on the model-based systems engineering, on the organization, on the tools to be used to fulfill that. But now moving to the automated and autonomous vehicle trend. And I don't have to teach you about all the different levels, just want to have a quick reminder. So up to level 2, it's the driver's liability if something happens on the road, and beyond that, it's the vehicles or the systems liability. And so this step from 2 to 3 is really huge. That is a big step forward. The legislators have made that now possible in some countries around the globe, that vehicles with a level 3 system and beyond are allowed to drive on the roads. And so there was a lot of hype, of course. You also may know the hype cycle from Gartner, which is very well known. But I would say when we look at the hype cycle, we are now towards the valley of death. For the autonomous vehicles. So there are a lot of news now that you read. Things are not happening as fast as prognosed. So many companies are laying off people because it's not making the progress they expect, which for me is the good news. The good news is we have to go, every big innovation has to go through this cycle of hype, and we have to go through this valley of death. To then reach really the maturity that is needed to introduce those technologies for the long term. So for me, actually where we are is good news, because it's just another few years to really then come and bring those vehicles into the mass markets. And this is also one forecast and projection that FEV Consulting is providing, and some views on that. How do we see the different market share levels coming? At the moment, I would say in China, US, Europe, 100% of the vehicles are up to level 2. We are now seeing that first level 3 vehicles are on the road, allowed to drive, and we will see a gradual move up towards the level 4. Level 4, we will only see not for private cars, but we will see it more for the robotaxis, for the commercial vehicle industry. And for the private cars, we will probably see for quite a long time the level 3 vehicles. I think here in India, and this is just one example, there are also others out there, we also see already some level 2 features available on some of the vehicles, which is great. I see there's a big effort and also the ambition to keep up developing and accelerating the automation levels. So this is good to see, and I think there is more to come in the future. Companies are adapting those technologies now, and that is a good sign. So this year we have seen the first level 3 vehicle on a German highway with the S-Class from Mercedes-Benz. Actually is now allowed to drive on a level 3, which was a huge step. If you have a chance to visit San Francisco, I recommend to take a drive in GM Cruise Robotaxi, which is a level 4 vehicle. Although the operational design domain is very limited to San Francisco, it's operating, it's live, you can experience it. And also in China, quite recently, there are companies now who got a driving license or a driver's license for some robotaxis in China. So things are happening, although in a very limited operational design domain yet, but there are now, I think, vehicles on the road. It's good, we will see it progressing forward. And if we have a level 4 vehicle, then also all of a sudden the design of the vehicle, the interior, the concept will change. And we are talking about the third living space of the people. So the first living space is your home. The second living space somehow, because we spend quite a lot of time, is at our work. And now we have a third living space that can give us back time, valuable time when we are commuting in the car, all of a sudden, this is an additional living space. And this is just one example. There are many, many concepts out there of vehicles with level 4 features that allow a completely different setting. And this should just give you some ideas of how this may look like. Yeah? So really transforming the interior of the vehicle into something more nicely. Yeah, moving on to shared and intermodal mobility, and Mr. Petka also mentioned that that we basically have to also change the way we commute. The urbanization is putting huge pressure on how we are moving people from A to B. And here are just two examples how things can look very differently. Yeah? When we take London and Los Angeles as two mega cities, so to speak, how are people moving around, yeah? And the share, the modal share of the city between, let's say, using public transport, walking and cycling versus I use my private motorized car. Yeah? So obviously in the US, we see this huge long traffic jams with everybody sitting, one person in the car sitting in the big pickup truck. And in London, due to, let's say, also the regulation there, we see a different change. So we need to be ready as the automotive industry to accept that the model of Los Angeles is no longer the future. So we need to find also solutions how to connect in an intermodal way, to connect with railway systems, with other mass transit systems. Yeah, and there are already a lot of solutions out there, basically trying to develop solutions for this white space between, let's say, the pure car ownership or car rental and the mass transit. So a lot of things are happening in this space. There are a lot of startups out there developing things, and also FEV is quite active in this field, coming up with new vehicle concepts, yeah, from micromobility, from innovative scooters that basically are foldable and you basically can take them into the bus or into the metro, to electric bicycles, to e-mopeds, to robo-shuttles, to small car-sharing vehicles, and even we are working on concepts for the urban air mobility. Yeah? So the vehicle you see on the top right side is a vehicle concept that we have developed funded by the German government, and I think this is where we have to move. Yeah, we have to, let's say, open up and allow all sorts of mobility concepts coming to the market. Now, I want to pick up on the electrification, and I think Vijay, Mr. Sharma already presented also the view on that for the Indian market. Just as a reference point, and we are talking when we present those forecasts that we are developing, usually we have a base scenario and an accelerated scenario. For Europe, and we have basically put away the moderate scenario because we see the accelerated scenario, we just have to update and increase the shares for electrification every quarter. Yeah. In Germany today, we have 25% of the sales, they have, the vehicle can be charged. So it's either a plug-in hybrid vehicle or it's a battery electric vehicle. 13% is battery electric vehicle, 12% is plug-in hybrid vehicles. So it's moving very fast. And let's say one element that is at the moment maybe holding us back is the OEMs can't deliver fast enough the vehicles, and the infrastructure, the charging infrastructure is a key barrier, but the people are poised and super interested to buy those electric vehicles. Yeah. And I think I don't want to repeat this slide. Mr. Sharma already showed it. Also, India is not far behind the pack, leading the electrification, and there is so much more to come. And when you look at the absolute numbers for the Indian market, this is amazing. This is huge volumes that we will see. So yeah, the electrification becomes a big topic. I give you one perspective of, let's say, what is a big challenge and task in Europe. Yeah? Having all those electric vehicles in the production means we need batteries, and we cannot import them from China. We need to produce them in Europe. And here you just see the announcements of all the battery manufacturing sites in the recent months. We are talking about almost 1.5 terawatt hours per year production capacity that is being announced. from our side, okay, the announcements are usually a little bit exaggerated, and it's more than which is demanded by the industry. But this gives you a flavor of what is happening, and it also should give you a flavor of what is required for the Indian market, if you translate that, yeah? And are you ready for that? Yeah, talking about some technology developments on electrification, and here are some energy targets that were recently announced. On the one side of the gravimetric energies and the volumetric energy density. And here we also, of course, see a clear trend towards increasing energy densities. NEO is talking about ultra high energy density solid state cell, whatever solid state means in this definition, but that's moving up to 360 watt hours per kilogram. BMW talks about a significant increase and introducing solid state batteries towards 2030. And also Porsche is talking about 500 watt hours per kilogram on cell level, not on pack level. And also on the volumetric targets, we hear figures that go beyond the 1,000 watt hours per liter. So when we look in general and take all those announcements and try to project a little bit what is the trend, what are we seeing, we can first of all say clearly that NMC technology will remain the dominant technology for the upcoming years. So there's no big change. However, the formulation of the NMC will change towards a more nickel-rich and less cobalt usage in those cells. And we will also see some interesting blends between NMC and LFP in the future. So on the one side, we will see the introduction of LFP cells, especially for, let's say, the lower segments, so A, B, C vehicle segments. So we will see LFP because it offers cells at a lower price, and you don't need to have the high energy density for some of those vehicles applications. But I think what is really interesting to see how we can also mix and match those two technologies between NMC and LFP. And then, of course, there is a solid state out there moving up, offering much higher energy densities. And we will see in which form we will see the solid state battery. I think there are also all sorts of gray when we talk about solid state. And the announcement that we hear that we have already vehicles on the road, they are kind of semi-solid state, I would say. No? But clearly, until 2030, we are not really seeing that there is a really on the road in high volume serious production solid states available, because also the price for the watt hour is quite huge. So the delta needs to be closed. There are, and I think this is also part of the handout, then also some pros and cons of NMC and LFP cells. So what we are seeing is, especially for light commercial vehicle in Europe, there's a huge interest on LFP cells. I think Tesla has introduced the base model for the Tesla 3, the LFP cells also coming to Europe. So I think you should have it on your radar. And over and beyond the NMC and LFP, of course, there are also some other technologies out there. I think there's not a week without an announcement of, hey, we found another holy grail. I would be very cautious about it. But nevertheless, of course, the aim is to move away from lithium. The aim is to move away from cobalt. So all these very expensive raw materials. And if we are able to have a nice, for example, sodium-ion battery, some made a huge investment here from India. I think Reliance put some money into that basket. We will see how this will develop. For sure, for the pure automotive application, sodium-ion cells probably are not the solution, but for bus application, for three-wheeler applications, that might be quite a viable solution and a very cost-efficient one. Going forward, we will also see, and this is from investor presentation of GM, I think that's no secret, everybody can look that up, but this is basically giving you an idea and a cost walk where you are actually seeing the improvements of reducing the cost. And I think it's basically in two directions. On the one side, it's the cost reducing on pack and module level. And on the other side, it's basically the cell itself, where we see, due to the change on materials and the production technology, we can achieve significant further cost reduction. And I would say, if you compare how much R&D money yet the automotive industry has invested into the cell and the battery, compared to what we have invested over the last 100 years into the engine, I think we are still, let's say, at a very early stage of the technology curve for the battery. So I expect that there will be much, much more to come. Yeah? Just so many bright minds now entering this field and doing research on this, and there is so much more we can learn. So I'm very positive and super convinced that we will see a huge improvement in the future. Yeah? And that, I have to say, is maybe the problem then the fuel cell electric vehicle will have to compete with the progress we are making on the battery electric vehicle. But I think there are much more other interesting solutions where the fuel cell and the hydrogen can have a huge impact. Not so sure whether it will be the passenger car segment. And one last thing, and one way also to reduce the cost on the pack and module level is actually to remove the module. So new designs are there where we talk about the cell-to-pack approach. We will also see then different form factors of the battery. So we call these blade batteries, yeah, so very long batteries that will be used on the cell-to-pack. And yeah, I think it has quite a number of advantages, but we also need to be careful when we talk about building up a battery portfolio, using it in multiple vehicle applications, doing this in a very smart way. We also have to understand that this maybe also comes at a cost, because then we have very dedicated solutions here for certain vehicle platforms. So I would say for high volume products, this might be a really good solution. If you have, let's say, a quite diversified product portfolio, you may be still better off using also in the future battery modules. Yeah? I think this is something where also FEV would then help you to find the right sweet spot to make the decision. Yeah, coming to my last point, sustainable vehicles and circular economy. Yeah, maybe always nice to see some good pictures. Yeah, so this was the BMW iVision circular concept that was shown last year on the IAA Auto Show, and yeah, I think all the big OEMs are now moving towards talking about circular economy, the sustainability, recyclability. So this is a huge trend, and it's all about not only net zero emissions, but also on reducing the material, the virgin materials in the vehicle, having really high shares of recycled materials. Yeah. Another example, and here this is a nice vision from Renault on the Scenic, which is also a hydrogen fuel cell powered concept car. But for me, more importantly, is also here the target towards reducing the accidents by up to 70% with all the sensor technology on it, and B, also have a very high share of recycled materials. Yeah? And I think this is, when we look at those concept vehicles, this is what we have to expect then in, let's say, 1 or 2 vehicle generations out there in the future, that we have to move towards this. This means we need to innovate on material technology. We need to innovate on basically how are we collecting used cars, used parts, how we basically feed them back into the material supply chain process. Yeah, and then I think also one nice example is Tesla building up a full energy ecosystem. For me, this is also part of innovating to zero. understanding, yeah, how can I basically connect the different dots and not just offering a car, not just offering an app on my mobile phone, have a software service, but also offering other hardware components that are then building this energy ecosystem. So be it at home with your solar panels, with your power wall, and then with your wall box, but also allowing then this bi-directional charging and exchange of energy between the vehicle and the home. And I think this is truly something that is necessary, that we have opportunities and use the vehicles of the future also for the grid balancing, which is a huge task, and being able, yeah, also when there are power outages, that the vehicles are available. We have seen that when we had the Hurricane Katrina in the US, Teslas were being used to power the homes and give back energy. So I think there's a lot more we can do to really connect also the home and the vehicle and then basically your community. Yeah, there are of course further ideas and examples from other OEMs on sustainable interiors. Yeah, so the big topic is of course reusing those materials, recycled plastics, but also using more vegan products, moving away from leather to more synthetic applications there. Yeah, reducing the overall CO2 footprint, yeah, for the full supply chain of those materials. I think this is what we have to do, yeah. And yeah, for you, the question is, where do you stand on the level of automotive circularity? Yeah, I think most of us, we are still at a level 0 to level 1. Yeah, we basically make something, we use it, and then we basically throw it away. But we have to move away. In Europe, we have strong regulations now coming from the European Parliament on recycling targets that we have to achieve, not only on the battery, but on the full vehicle. It's being pushed very hard. It's part of the Green Deal, I think everybody is moving towards that system. And in the past, yeah, we had that triangle that we had to manage. It was time, quality, and cost. This is no longer a triangle. We now need to squaring the circle, yeah, which is now having a fourth dimension, which is sustainability. And in Europe, we see all the big OEMs, they are now not only deciding for the suppliers based on the triangle, but also adding the CO2 footprint and the sustainability into the equation. And this is something that will create more and more interest going forward. There's more and more pressure. We have the United Nations targets on sustainability, and people are signing up. And they also want to move away from just greenwashing and having nice corporate social responsibility report that they can show, but they actually want to show and give the evidence that they have an impact. Yeah, and if we want to achieve those targets that Mr. Petka also mentioned, 2050 net zero, 2060, then we have to start, because this is not coming just with a snip and we have it tomorrow. This is very, very hard work and the complete reconfiguration of the supply chain. Yeah, and here FEV is also quite active on building up a framework, offering different services for life cycle analysis, for helping you building up an assessment and a framework for your circular economy. So, and with that, I say thank you. And are you ready to innovate for zero? We are definitely. Thank you so much.
Thank you so much, Mr. Alexander Nasir, for your interesting perspective. Now open to audience. So would you like to ask some questions related to the topic? Anybody?
Information overflow.
Okay, thank you.
Okay,
thank you,
thank
Mr.
you very
Nasir.
much. And I'm happy to have questions also during the coffee break. Thank you.
And now it's time for a quick quiz on FEV basics. Now each correct answer fetches you a nice prize. So get ready to put your knowledge to the test. Now first question is, what is our FEV vision? Anybody? FEV vision.
Ladies and gentlemen, I hope you are actively involved. So FEV vision statement was first put in words by Mr. Vijay Sharma. So anybody would like to answer?
Anybody?
Come on, we are engineers.
Please raise.
Definitely enthusiastic engineers. Anyone?
We all are FEVians. Come on.
Anybody? There is one person.
From everybody. Open to everyone.
Please, yeah. Swagata.
Yeah, correct,
Please hand
sir.
the mic.
Definitely you will get. Deepak? Sir, give the answer.
FEV's vision has been that we want to develop global partnerships across the world with our clients. We just don't want to have a buyer-seller relationship kind of thing. We always believe partnership always leads us to something where we say, okay, the client's problem is our problem and our problem is client's problem. And together we solve this and move forward. So this is global partnership.
Very well said. Thank you. This is just a small token of appreciation.
Thank you.
Now, the second question is, where is the headquarter of FEV located? Very easy. Dr. Shrikant Nagpuri.
From customers, anybody would like to answer?
It's headquartered in Germany.
Germany where? Germany is a big word.
Is it in Aachen?
Yes, it is Aachen. Yep. Thank you.
So who gave the answer for this?
Both Dr. Shrikant Nagpure and
Efforts will not be wasted. Definitely sweet tooth for you as well.
yeah.
Yes.
Thank you so much, everyone. Now, moving ahead, I request Ms. Sakshi, our next host, to take over. Thank you.
Hello everyone. Now, I would like to invite Mr. Bon Kishore, General Manager, Vehicle Development, FEV Group. Ladies and gentlemen, he is a Senior Design Manager and Chief Engineer, Vehicle Body Engineering, with hands-on experience on the topic under discussion, who is going to deliver on the electric vehicle architecture and integration. Please put your hands together for Mr. Bon Kishore.
So, thank you very much for the introduction. Back. Okay, I will bring the vehicle architecture because the electrification, the electric motors and batteries have a big influence to the architecture. And I will explain what we're doing in the FEV, in the vehicle architecture. I have here the agenda. And also, we must looking for the new trends, what Alex have mentioned. And the big influence is for sure the battery. That's a big one. And also the battery housing is implemented in the body in white. So I go to the next one. That's the 7 pillars by our engineering development. And now I will showing you the vehicle architecture, but also the architecture of influence of all these pillars. So that one is our project organization chart, and you can see exactly we have here a program manager which is responsible for the whole project, for the whole car, for the whole project. And the chief engineer is the technical responsible for the car. But now you can see here the vehicle architecture, which have a big influence to all of these components development, chassis, body, interior, and so on. So that's the the point which meet all these components. So that means vehicle architecture is very, very important. And now I will show you what we're doing in the vehicle architecture. That means what we do is, for example, the measurement concept. That means all the measurement which describe the car, wheelbase, and so on. And also what we have is for sure ergonomic, so the elbow freeness and so on. That's the vehicle architecture. And also BOM and PDM to documentate all the parts, all the weights, all the costs, which is in the BOM and in the PDM system, because for sure we are working around the world, and we need a PDM system which can have the whole world access to each part to develop it forward in a global team. Also what we have is here a package and DMU, which control every day if all the parts are for sure existing, find the right place, and are not have a collision or enough space to the other parts. Also we have this surfing, which is the connection between design and engineering. You know, these designers are free and innovative and so on, and we as engineering are straight and working with numbers. So that's the bridge between styling and engineering. And last but not least, the vehicle concept, which I'll concentrate today. What we're doing here, that means that we call it pre-development. And that is going around the complete car. That means pre-development in body and white, in interior, exterior. That's the job, what we're doing here in vehicle concept. And then I will show you some ideas in electric vehicle, especially in battery housing. So, what we're doing is we need in the vehicle concept, we must have simulation, because we must know exactly the material. So we make material cards, and with this we make the simulation that we can exactly say how it's working, for example, the body in white and so on. Then what we need also is the manufacturing, because when you make a good part, you must also manufacture it and produce it in a low-cost way. Then the optimization to bring the weight down and optimize the topology. And also the joining technology is very important, because also this one have a big influence to the architecture, to the body and white, to create the parts. So now I will show some trends in the powertrain, because that is the biggest influence what we have right now with the electrical cars to the architecture. That is showing also Alex before, so we can skip the left side. That's the moderate idea, how coming up the electrical vehicle in Europe. So we're looking only on the right side acceleration scenario, that we have 2035, 100% electrical driven cars. So that means, but the development starts earlier. So we are right now in the phase to make more or less 95% of the development are only electric vehicle or hybrid. So, the influence of the battery is very big. I have shown here a VW Golf 2 from 1990. The weight was here from 845 kilogram up to 1,000, depends on the equipment what you have inside. And it's going up in more or less 30 years, I will say, to 1,200. That means 400 kilo more in 30 years. But now we get a battery underneath the car. So that means the battery more or less depends a little bit on the size of the car. we have additional weight of 500 kilogram, only to switch from ICE to BEV. So that means we must do something about the weight. We must do something about architecture. We must change also the architecture. And we must change the material. We must change the connections. All of these have a big influence. So we can see here when we save a weight, for example, 100 kilogram, we need that's 2.8 kilowatt hours battery capacity. We can reduce it, or we can increase the range of 14 kilometers, or we save, because that's an energy mix in Europe, 432 kilogram CO2 saving. Or we save money 22 cents per kilometer. But for sure, lightweight means money. When you go from steel to aluminum, it costs money. It costs CO2 when you make aluminum. So we must balancing what is the right technology. The right technology is always which car you want to have in the end. You have a sports car, you have a family car, you have a low volume, you have a high volume. That's decided which way technology you should go forward. So that's a chart to see where are the biggest weight in the car. And you see here on the right side, powertrain with 31% of the total weight are with powertrain, coming from powertrain, chassis 20%, and body in white more or less 20%. The other one are very close, doors and closures only 8%, and interior, exterior also the same level. So that's our three main topics which we should working on. Because we can save a lot of weight in these three areas. And then we're going down to powertrain. You see EDU are 16%, and battery for sure 78% of the total weight of powertrain. Chassis, you can see also the main driver are suspension and brake and wheel and tires. And on the right side, body, we have underbody with 60%. That means when you see, and that is always calling a rolling chassis, we said the rolling chassis have 60% of the total weight of the car. It means powertrain, battery, and EDU, chassis, suspension, and wheel brakes, and body, only the underbody, 60% of the total weight. So we're going forward with trends and forecast. General battery trends, for sure we can see on the left side, that's a battery which comes underneath or between the tunnel. I go to the right side, under the rear seat, under the trunk. That's have some advantages, some disadvantages, but in the end, the electrical BEV vehicles, the battery is under the floor. That's the trend, and I guess 95% of all the BEVs have the battery underneath the floor. All other are special solutions. So, but that means under the floor, we must change the complete architecture. You must think about the ICE is not in front anymore, so you can move the passenger more in front, so you have more other crash behavior. The battery goes in the side, so we have a problem with the pole crash. So that's all the topics what we're doing with the pre-development to check if these new architectures are working in a good way. For sure, that is what I said, that battery pack for energy storage only is only a battery pack. That's not so good for the architecture, for the body and mind, because it's only a battery pack to bring the car forward. On the right side, what we want is that the battery housing takes over some load passes, some work in the body in white in the complete car. So that's the trend, that the housing is not only a housing for battery, that must take over some task in the car. So that's the way how we going forward. As Alex also said, we have cell to module. Right now we make 80% of the development is cell to pack, because the energy density and energy volume is bigger. And here with cell to pack we have a bigger influence of the housing in the crash behavior and body in white. So that means take over a lot of work and stability. But also we have some smaller, or not smaller, some less projects about cell to vehicle. That means the battery is a part of the body in white, so that's not separated. You have for sure some disadvantages, because on the right side you cannot change the battery anymore. You can change, but you must replace it with the same battery, because the housing is a structural element in the body in white. So that means what our focus is, we're going from module to pack, and then to cell to vehicle, to increase the energy density and on pack level also. We have done a little bit more flexibility in this case, and for sure cell to pack is the way to cell to vehicle. Okay, now some ideas and some trends about material and connection and joining technologies. At first, for sure, we must looking complete. We cannot separate some components and looking only for that one. We must have a whole idea how to bring the weight down and integrate the battery. And therefore, we must looking for reduced joining effort, low cycle time for sure, that's costs, low material cost for sure, but it depends on lightweight design, because lightweight design means the cost going up. For sure what we have is life cycle emission, that's a big topic, scalability and modularity, that's a big topic, and for sure function integration, what I said before. So material trends. What we see right now is that we have a lot of battery housing which we make with aluminium. For sure that's a lightweight design to bring the weight down. But steel is not out of the race. I think steel and aluminium have always a race, and sometimes aluminium in front and sometimes steel. Steel is for sure for high volume cars because it's cheap, very easy to handle, and so on, very easy to connect, and the corrosion is very good to handle, and the low life cycle emissions is also better than aluminium. And what we see now is the fiber reinforced plastic, for sure for low volume, special for special topics, for special cars. I will show later on an example. It's good for lightweight and also low life cycle CO2 emission. For sure you can do a lot with aluminium, for example, to bring down the cost and the CO2. Recycled alloys you can use, no age hardenable alloys you can use to bring down the cycle time and also the CO2, or high performance alloys, then you have the cost high but the weight going down. So that's the manufacturing trends. What we see for sure, aluminium. We have a lot of extrusion parts. That's very easy to handle, to produce. depends a little bit on what you want to have on this path. When you need a hole, and so then it's going up with the price. Cold, warm, and hot stamping coming up to increase the stability, the crash performance. Die forging, composite casting, that is what I said before, is coming up, but is a new technology, and we see it not so often in the cars right now. So that's the joining technology for sure. Spot welding, I think we're doing that more than 20 years or longer. MIG welding, yes, is low cost, but it's a little bit about corrosion topics. Laser welding, also low cost, but you need a good manufacturing, because the tolerances are very low that you can laser welding. Hybrid welding, friction stir welding, for sure the complete adhesive bonding, the gluing and so on is coming up or is implemented right now. Rivets for the aluminium parts, flow drill screw, that's all technologies to bring not only aluminium together, also for hybrid solutions, steel with aluminium and so on. So to find the right solution, you have a lot of requirements from the regulation, from the governments, from the different regions, and from yourself, from the OEMs. So we must find out the right solution for the right car, I will say. Sometimes the part costs are very important, and so we must go with the part cost. Sometimes you make a sport car, and that's the performance very high, or you need from the styling a flat car, then the TED stack is important. So that around, we make an analysis with the OEM together to find out the best solution. And now I will show you some solutions, what we have done. For example, on topic left, that's a hybrid casting solution, which we have done. That's you can combine steel with aluminium casting to bring the power or the reinforcement to this point which you needed. And so you can save money and weight, because the ribs are only there where you need it. Then bionic node design, for sure, that's the additive manufacturing. That's very impressive to see that. But it's for sure for a low volume. But then you have a really weight decreasing and a really good crash performance when you use this technology. Powertrain, for sure, we 3-in-1 design, e-motor, transmission, and power electronics should be in one part, to going down with the package volume for sure, and also with the weight going down. And also optimized structural integration of the Hochvolt battery. Also with the chassis, we must working ongoing, because the forged aluminium links and to bring down the weight, optimized struts, wheel carriers, damper design, and so on. That's all the points which we are working on to bring the weight down, the cost down, and to have the optimized car for each customer. That is what we've seen before. Also, we must looking very deep and very closely to the development of the batteries, the trends of batteries, because then we must decide how we go on with the architecture, how we go on with the development of body in white, to see, okay, the trend goes in this direction, we must change our architecture, we must change our measurement, and so on. Therefore, I have put in this slide that we must looking very closely to this development of batteries. So also what we see in the, and you see on the towing hook, that's a typical test or accident what's happened with the Tesla. And so we see that there's a lot of more tests coming up, and we must prepare the housing that we can fulfill all these tests and that the customer have no accident with that one. So we have a special blade underneath the housing to protect the towing hook and all these possibilities to have an accident with a part. And we make all this calculation. We make also this physical tests we have in Germany, in Aachen, so we can make the test and check if our solution are okay or not, or fulfill the requirement. That's a general chart, and we see that we come from the cell to module, going to cell to vehicle, over the pass cell to pack. So that's the way. On the right side is the highest structural integration what we have in the body in white. That means we have a lot of work to doing that, because we have one project about that one, and we see a lot of problems all over which we can solve, but we need time to doing and see that the OEMs are moving in this direction. So now some project we have done. For sure, we cannot show exactly the battery solution because it comes from a customer, it's secure. But this one is a new idea to make a battery housing to use extrusion parts, aluminum extrusion parts. It's all aluminum, and so we have a mass reduction of 9%. And a cost reduction of 14%. And in this case, we make complete the design of the housing. We make the cost calculation. We make the simulation of that one all over and send it to the OEM and have this result in the end. Also, the production is a topic of this project. There's another project about battery housing. Also here we have a cost saving of 40% in this battery housing. And in the end, this is a very high, a very good high performance project. Here we have a cell-to-vehicle approach and put it inside. That's a complete new underbody. And also, it's also a mega trend, that's the mega castings. So the front and the rear are one casting part, which have, you know it very well, a big effort on the design on how to handle this big part. Yeah, and that's for a high volume car platform. You can say more than, in the end, more than 2,000 cars per day. So now the conclusion. The new powertrain and the new electrification, the new battery have a significant weight increase of battery electric vehicles. We need a complete approach. We cannot look at only in components and to reduce the weight. We should have a complete approach to looking to the complete car to bring the weight significantly down. We come from cell to pack and go to cell to vehicle. Right now we have 85 or 90% cell to pack projects, but we see cell to vehicle will coming up. Also we need new materials, alloys, 7,000 alloys and so on. New materials and manufacturing process for the electric vehicle, also for cost reduction, for weight reduction, smart assembly concept and platform layouts to optimize. And for sure, as the sustainability is also a major challenge which we have in future. Okay, I'm ready. Thank you.
Open to audience. You can ask questions related to the topic. Please hand over the mic.
My name is Premlal from Tata Motors. My question is, do you have anything related to commercial vehicles?
Sorry, a little bit louder.
Yeah, can you hear me now?
Yeah, a little bit, yeah.
Okay, I was asking about whether you have any concepts related to commercial vehicles. Commercial vehicles.
Oh, thank you. Yeah.
He's asking if you are having any concept related to commercial vehicles.
Concept for?
Commercial vehicles. Commercial vehicles.
Can you sit here? Sorry.
Concepts for commercial vehicles.
Yeah, okay, understand now. Yes, we have concepts also for commercial vehicles. You know, I'm sitting in Stuttgart, and you know who is sitting in Stuttgart, and we're doing a lot of concept with them together. So we have in the pocket some ideas to make the commercial vehicles ready for E or for E powertrain.
Another question?
Maybe to comment on the commercial vehicles. What we are also seeing, and I think Bernd just said that we see a trend of maybe having the configuration of the battery cells in a different way. So there might be also other cell formats being more interesting, especially for light commercial vehicles. We talk about maybe different heights of the battery compared to passenger cars. So definitely we are looking into this very deeply, especially for the light commercial vehicle. We see that there is a huge push for quite some interesting battery concepts in that field. And also for, I think, the larger trucks, we see that there are, let's say, some interesting battery configurations that are not just hang-on battery modules to the trucks, to the frame, but also looking into new ways how to integrate the battery as part of the frame. And last but not least, also the hydrogen becoming for the very interesting concepts. Yeah.
And additional, we get a new regulation in Europe about the aerodynamic, because right now we have this flat nose in Germany or in Europe or also in India, but that's not good for the aerodynamic. So we need a car or a commercial car like US with a big nose to have a better aerodynamic to save energy for sure for the ICE, but also for the electric commercial.
Do you have any pictures or something of that?
Sorry, I don't get it.
He's saying, do you have any pictures to display?
No, I have no pictures for commercial vehicles.
I think we can discuss more in detail during.
Yeah.
We have to book a meeting room, I guess.
Any questions? Deepak?
Hi, I have the question on maintenance of these battery cells. Do we have any design concepts coming for cheaper cell level maintenance in our aftermarket? I mean, when we go into the aftermarket, after sales.
Sorry, to go back.
Do we have any concepts going on so we have more towards cell level maintenance? Do we have something there?
Yeah, okay. So later on we have other topic here, so Thomas will do it and will answer this question.
This is Manjunath from Tata Motors. My question is like in powertrain weight optimization. So you were talking about like light EDU design. What it actually meant like?
Light EDU?
EDU design.
Yeah. I don't get it. It's very hard to understand because it's not so loud.
While you were talking about powertrain weight optimization, so you have mentioned like light EDU design. So what it is that meant?
Yeah, light EDU design is, for example, to bring all these transmission and e-motors together in one part. That's light EDU, and also for sure all the materials must be light or must be changed that the light EDU is going down with the weight. That's our complete approach about light EDU.
So something like integrated axle and motor?
Exactly, yeah.
And one more question I have, like you in light weighting you have mentioned, like every 100 kgs will have some benefit in battery capacity and a range. So was it, example, relevant to cars or it's applicable for commercial vehicles? If it's so, at what extent it is applicable?
This example was for electric cars. To go down with the weight, 100 kilogram means you have a higher range or a lower density what you need for the same range.
That ratio remains same for commercials also because that GVW being high. Okay. Thank you. Thank you.
Just for the another 1 hour, I can cover all these topics. Yeah.
Thanks.
So this is Prakash from BV. You mentioned about castings for the purpose of lightweights. Lightweights for castings, aluminum castings. Aluminum is obviously 1/3 of steel, but the cost of squeeze or the pressure die cast is quite high. So how would you balance the cost versus weight?
I cannot hear it.
You mentioned about the cost reduction using the aluminum castings.
Yeah.
So you mentioned about the aluminum castings for the weight reduction. Aluminum is
the mega casting?
Yes, that's right. These are 1/3 of the steel, but the pressure die cast process itself costs more. So how would you balance between the weight and the overall cost of the vehicle?
You mean the overall cost? Yeah, that's for sure. You bring the cycle time down because you have one big part, but you must check, and you have a big integration of function in this part. But you must, after you produce this big casting part, depends a little. You must rework it. You need flat surfaces to mount something. So that's the additional work that you have then. But you have not this huge assembly lines, normal steel. You need these jigs and gauges and so on. So that's the point, and we expected that we save money with that one. That's our expectation.
Okay. Another question?
Hi, Shivaraj from Stellantis. See, so we have different modules. Yeah. See, we have different cell to pack or cell to module, or else the next one is cell to vehicle. So on the cell to module, yes, that is something isolated from the vehicle on the perspective of the safety of the battery. Even in the cell to cells, the next one, that is also something isolated from the battery. And the third one is a cell to vehicle. Yeah. So in this case, maybe on the safety side of the battery, we would discuss on the second session. The question is going to be on the architecture front. What it is the technical content or the architecture supports which is differs from the cell to module or cell to pack?
From cell to module or pack, you need additional crash support, or because the housing takes not over some stiffness or some crash performance. So that means you need additional package space, and also the pack and the module have needs a bigger space with less energy density. That means that's the task of architecture. And when you go to cell to vehicle, you have more freeness. For sure, the battery going bigger and bigger, so the freeness is gone. But anyway, that's for architecture a complete other story to make a cell to vehicle as a cell to pack, because the crash performance also in the housing integrated. And also sometimes, as you see on the picture, it takes the body in white takes over because when you mount it later on in the production, the cell to pack, you mount the battery earlier or in a supplier, so that's ready, this pack. But cell to vehicle, you produce it inside the fabric, so you must look that it's clean. You must look at this water resistant and so on. That's a challenge what you have with cell to vehicle, but the advantage is very big.
Okay, thank you.
I think we can take more questions after the break. Thank you, Mr. Bon Kishore, for sharing valuable thoughts on such topic on which automotive industry is brainstorming.
Thank you.
Thank you so much. Ladies and gentlemen, as we move towards the closure of the first segment of the Technology Day, let us connect with one another over a cup of coffee and meet again in 20 minutes. Thank you.
we deal, how we treat each other, how we work together, not only among each other but also with the clients. If you're aware of them, you can much more consciously live the values, and also if you make them aware, you can agree on the common values that are important.
没有 value， 没有价值，那么企业很难成长，很难存活。
From my perspective, being in business development, customer focus is the strongest value that FEV has. Caring for the customer, showing that customer that you're there for them from the very first time you meet that customer and shake their hand, all the way through project delivery.
Aber auch wenn wir im Team zusammenspielen, muss eine gewisse Professionalität an den Tag gelegt werden, damit die Sachen funktionieren, damit die ineinander greifen, damit man Übergaben vernünftig machen kann, damit das Arbeiten funktioniert und das Projekt halt vernünftig abgearbeitet werden kann.
Commitment is something that comes from within. We all take unwritten commitment that we will do whatever we can to research, to endeavor, to find out what the best solutions or the best methods are to get to the end.
开放就是我的理解就是可以去容纳其他人不同的想法，你有你的观点，别人有别人的观点。那么如何呢？你呢去容纳其他的，静下心来去听别人的观点，容纳别人的观点，最终再找一个呢最好的一个方案。
Le respect, c'est donner à chacun la position qu'il a. L'entreprise, c'est comme un puzzle où chacun est un carreau du puzzle. Et le respect, c'est de dire à chacun, oui, tu es important, oui, la position que tu as est importante pour l'entreprise.
Wir sind immer am Puls der Technik. Wir sind immer ganz vorne, was die Automobilindustrie angeht.
This isn't just a job. It's family. It's making sure that you are comfortable, you're with family, and you progress together.
Hello.
So FEV is a well-known company developing a powertrain. So we've been contacted by GCK to support them with their project to go to Dakar with a fuel cell. FEV is a private-owned company. It has been founded in 1978 by Professor Franz Püschingham as a kind of spin-off from the university. We are more than 6,000 people worldwide. So moving from combustion to all kinds of powertrain development and all kinds of activities which are related to chassis development and connected mobility. Today we are more orientated towards zero CO2 mobility, and that's what we will see later on towards our activities with GCK and what we want to demonstrate.
L'hydrogène est une des technologies du futur dans les nouvelles mobilités, qui vient aux côtés de différentes activités que sont la batterie et les moteurs électriques. Donc GCK tout naturellement est inscrit dans cette transition. Ça fait quelques années que l'on travaille sur ces technologies. L'hydrogène pour GCK, c'est un grand pas aujourd'hui. C'est se positionner dans la technologie du futur et c'est être capable aussi d'accompagner les véhicules heavy duty, c'est-à-dire les véhicules lourds, dans leur transition vers l'électrification.
Hello.
On aura des essais pour vérifier
everyone to please gather in the hall.
Des essais en vibration. Pour pouvoir construire le plan de validation du système, on va s'appuyer sur l'analyse fonctionnelle de ce système-là, c'est-à-dire comment on estime que le système doit se comporter dans son environnement et dans le véhicule présent. Et finalement, le plan de validation va nous permettre de vérifier les contre-mesures qu'on aura mis en place sur notre conception pour pouvoir éviter les risques qu'on aura identifiés pendant cette phase d'analyse fonctionnelle. Donc le nombre de tests varie en fonction des éléments qu'on a besoin de vérifier.
What we are doing here, we are putting two words together. FEV as an expertise on the powertrain development and GCK as an expertise on racing. And for especially everything which is dedicated to Dakar.
L'intégration du véhicule peut amener énormément de paramètres extérieurs qu'on ne peut pas voir sur un banc d'essai fixe, notamment pour tout ce qui est sollicitation extérieure, tout ce qui est refroidissement, flux d'air et ainsi de suite.
It's the challenge that we will have. So we are dealing with a 200 kilowatt powertrain, which really for the moment something a kind of new activity on the market.
Alors sur le projet Dakar, nous avons un nombre d'ingénieurs qui varie en fonction de l'avancement du projet et de la phase dans laquelle on se trouve. Pour donner un chiffre à peu près moyenné, nous aurons 20 ingénieurs qui travailleront sur ce projet, répartis entre la France et l'Allemagne, avec une répartition à peu près de 50% en France et 50% en Allemagne.
Hello? 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 I request everyone to please gather in the hall as we are running out of the time.
Hello. Gentlemen, please, ladies and gentlemen, please move towards the presentation area.
I request everyone, please get settled quickly as we have to commence our next session.
Hello. I request everyone to please be seated so that we can start our next session.
Ladies and gentlemen, I hope you all are settled well. We will be starting our next session now. Hello and welcome back, everyone. Hope we all are re-energized to listen to our next keynote speaker. Let us now make renewed forays into multidisciplinary approach towards EV simulation, as will be elaborated by our next speaker, Mr. Michael Hogg. He is an alumnus of the University of Stuttgart. He speaks today with an experience of almost 2.5 decades. His expertise areas are vehicle integration and vehicle safety. So herzlich willkommen, Mr. Michael Hogg, Global Vice President, Vehicle Development, FEV Group. I request him to please come on the dais.
Good morning, everybody, and thank you very much for the nice introduction. It's a pleasure and it's an honor for me to speak in front of this dedicated audience. And I'm really happy that the COVID time is over, because it's something completely different, speaking to an audience via Teams and standing directly in front of you. So I'm really happy that this time is over and hope this will stay. The topic of my presentation is EV simulation, a multidisciplinary approach. So when I started my professional career, more than 25 years ago, it's unbelievable, 30 years ago, I started as a CAE crash engineer. And at that time, simulation was not an established part of the process chain. So there were simulations and there were some load cases at that time, but so my feeling was, so the design engineers and the test engineers, they only asked the CAE guys if something severe went wrong. At that time we were asked. And from that moment on, the situation changed dramatically. Not because I stepped into the industry, but it was the time. So the hardware was available, the software was available, and the experience was available. And from that moment on, simulation, structural, thermal simulation, every kind of simulation became a really integral part of the development process of a vehicle. And it's a key technology now to reduce development times and also to reduce the number of prototypes dramatically. And it's also the only technology who makes it happen that complete prototypes phase can be deleted for vehicles, so that lead vehicles are now developed completely only perhaps with one prototype phase, and it's now state of the art that derivatives are developed completely without prototypes. And that's only possible with the intensive use of CAE technologies. But now there is a new change in simulation technologies, because with the occurrence of electrical vehicles, new load cases have to be simulated. And the importance of the different load cases and different CAE domains are swapping. So Simulations, who are really not important for ICE vehicles, are now very, very important. So that we have to have there is a complete new trend and a complete new view on the simulation world coming from the EV development. And I want to show you here what we do in the area of simulation for BEVs along our, we call it CAD and CAE driven development process. I'm too old, I cannot read that. So the 30 years are true, yeah, I'm really, so I have some problems to read it, but I have to turn around a little bit that I can really read it. And I cleaned my glasses, that was not enough. Here we start from requirement specification and target setting until verification and investigation in complete vehicle. And here CAD activities and CAE activities are going hand in hand. The first thing I want to show you, okay, thank you. The first thing I want to show you here, what is one thing what we do in a very, very early phase. You know, the first thing which is available from a vehicle normally is the styling. So there are some styling data, class A surfaces of the vehicle, and from that moment on, we start with CFD simulation. That's, in most times, the first step in simulation in a complete BEV development process. At FEV, we defined a very highly automated process for CAD, for CFD simulation, starting with a CAD styling input. So the fully adaptation of the geometry, surface preparation, and at the end we have an accurate watertight surface Okay, I take the microphone, yeah, that's much better perhaps. Okay, then we have an accurate watertight surface mesh export. The next step is meshing. Is it okay? Can you hear me? Okay. The next step is meshing. We start a PID-based automated meshing process with local refinements. Local refinements are necessary to fulfill or to make a model suitable for all the different turbulence models. Next step is simulation. We use all the turbulence models, and we have different approaches for moving geometry, wheels or wipers or so on, so MRF methodology, sliding meshes. And we use STAR CCM and OpenFOAM. And at the end, we have post-processing result assessment. And even here, we have a highly automated post-processing script. At the end, we produce automatically up to 600 images of the vehicle and the different physics in the simulation. And these are only some examples. 4 of these 600 automated pictures. You see here pressure coefficient, isosurfaces, and velocity streamlines. And we use this technology or this methodology to, in a very early phase of the program, to reduce the drag coefficient to a minimum. Because for battery electrical vehicles, this is one of the key values to reduce or to increase the range. So it's in the performance and efficiency. Though this is one of the most important things which has to be done in the early phase of the vehicle development. For the next step or phase, we start with topology optimization. For example, in here, we know the volume of the vehicle, the available space, and then we can start with the topology optimization model to find out where are the structural load paths needed. They are identified. Then we have a volumetric model, and that visualizes the space claimed for the structure. And from this model, we isolate some key joint models, and there with these models, we optimize the joints. And together with these two models, we have a initial geometry, initial state for the CAD designers or for the designers for their first panel development and their first body in white structure. And also with this model, we can perform in a very early phase NVH and safety analysis to conduct with primary 3D body development. And this is a fast and efficient concept approach for modeling and analysis. Okay, in the same phase, we start very early with simulation of the interior flow, because the next step to increase the performance and efficiency of a battery electric vehicle is the thermal problem, the heating. Here in a very early phase, beside the ergonomic bug we also already built in parallel, we can optimize the flow in the vehicle and reduce the effort or the energy we need for heating. The next step, now we're coming to the optimization loop. The first CAD model is ready, and we start DOE, sensitive analysis, and structural optimization. And this is a loop. We do this several times. The first and the most important crash load case for all battery electric vehicles is the side pole. Also completely different to ICE vehicles. There was a major focus always on the front crash load cases and maybe some side load cases, but for a battery electric vehicle, the pole crash is the most important load case because you have to save the battery in a side crash. And here we have one example. So we identify very early the dedicated structure for the pole crash to save the battery. And we use the technology and make a concept topology optimization to get the best result and the best trade-off between package performance and weight. Okay, this is also one example. Here you see we followed two concepts for the side crash to improve the side crash behavior. One concept was a load case. A load case which is going over the battery. It's concept number one. And the second concept was a load case or a concept where the major load case is in the floor and the battery is not a part of the, or not in the early phases, a part of the load, load flow. And at the end, we decided to go into direction of concept number two, because it has it saves the battery much better than every other concept. Okay, you see here concept one, only 40% of the load is in the floor. In concept two, 45% of the load is in the floor, and the battery is hit much later than in the concept number one, and the risk of battery model damage is much lower than in concept number one. So the next area is now again, we started with a CFD simulation at the beginning of the process, and now we can verify our CFD simulation after all these loops, and we go with a clay model into the wind tunnel and compare the results of the simulation with the wind tunnel results. And you see here, that's also a real life project. We defined 15 countermeasures to increase or to improve the behavior of the vehicle. Also, we took also these 15 measures and put it into the clay model, and the improvement for the complete vehicle with these 15 measures was an increasement or the improvement of the drag coefficient by 0.061, and this is huge, and 0.061 improvement of the drag coefficient means 42 kilometers increased range. And so improving the drag coefficient and the aerodynamic of the vehicle is the cheapest way to increase the range. Every other method costs way more money, and that's really every hour spent for CFD simulation and every hour spent in the wind tunnel is worth it, yeah, because absolutely the cheapest method to increase range. And here you see the comparison between simulation and clay wind tunnel, and you see our method is very accurate. Yeah. And so the results are very similar, and we are always on the conservative side. Yeah. So the results in the real world are always better than the results in the simulation. So it absolutely makes sense to use this methodology to improve the aerodynamic of a vehicle. Okay, next point here. At the end, now we investigate in the complete vehicle, yeah, with some load cases. One example here is durability, and durability is also more important for a battery electric vehicle than in the past for ICE vehicles because of the weight and the battery. So also durability has to be simulated very accurately, and normally we use these 1G loads to each wheel, and at the end we get here a durability and equivalent life for parts and see the critical areas and can then locally optimize the structure here with these results. Okay, we do the same also with a lot of components. Of course, the doors have to be simulated, the trunk over opening, full vehicle durability is done in this phase with the road loads coming from the proving ground, towing hook, floor pan strength analysis, and clutch and brake pedal analysis. And an example from commercial vehicles, we do the same for commercial vehicles here in the subsystem, the chassis subsystem, also with 1G loads. And here we also get results for the durability of the different parts of the brackets and so on, and can also optimize, again, our structure. Tools we use here, ENCODE and FEMFAT, but this is, I think, industry standard. Okay, and also important in this phase where we make the fine-tuning of the structure now, aerodynamic is optimized. The next step is aeroacoustics. You know, battery electrical vehicles, there the noise from the ICE engine is missing. So aeroacoustic has a complete different importance in the development chain. And here you see that it's not surprising, but the most critical regions in a vehicle is the side mirror, the spoiler, the air curtain, and the wheels. There the noise is coming from. And I also want to show you this. This is also a test we have done with an existing vehicle in a wind tunnel in Stuttgart at the university. And you see again, there is a very good simulation, and the tests are fitting very well together. So also this method can be used to optimize the aeroacoustic behavior of the vehicle. Okay, here on this page I give you an overview about the changes in the CRE world through EV development. What changed really? There are new requirements in crash for battery safety. So the pole crash is only one example. There are challenges by higher vehicle weights in BEV. That means more front load cases, and also durability is getting more critical. There are new topics and new methodology for thermal propagation. I will show it later. There are changes in acoustic due to missing combustion engine noise and frequency. We have to spend a very high effort in increasing efficiency on range. The cooling system is also very important, also for the improvement of the range and efficiency. So we also have to spend a lot of effort to simulate these systems, and Christian Saar will later show what we really do here in this area. Not really for battery electric vehicles, but also autonomous vehicles are coming up, and so we need new restraint systems and have to simulate new restraint systems for these vehicles. It's a big difference if you sit 90% in the vehicle or you're only 50% out of the direction. So you need a complete new restraint system, and there are complete new requirements for the restraint system. And new materials are coming up. Not yet, but I think in the next 10, 15 years, additive manufactured parts will be available. And also for these materials, we need technologies and methods, especially in the area of material cards and material card evaluation. Okay, here I want to show you what are the new load cases for a battery system, which are completely new now for battery electric vehicle. So the first thing, like always, is we need now material cards, even for the structural simulation of batteries, because in the past no one knew what's the behavior of a battery cell. So this material behavior and these material models have to be developed. That's also new for battery electric vehicles. And here, vibrations, harmonic and random vibrations have to be simulated for the battery. We do this as well in our test center in the EDLP, but we also simulate this from the beginning. Endurance fatigue is important for the battery. Shock pulse is important, and of course, crash and crash. And crash is also a legal requirement for battery and has to be simulated as well as tested for batteries. And last but not least, cell aging is also now a topic for the simulation of batteries. So this is one example. Here we simulate a certification test, a crash, and you see here we have these cylindrical cells. For the complete battery, we evaluated the material models for these batteries, and with this model we can perform the crash simulation and get the result what's happening with the different cells in the case of a crash simulation. On the thermal side, there are also many load cases which have to be simulated for a battery, starting again with a cell characterization. And then we can simulate the 1D electrical and thermal layout. The vehicle cooling circuit layout will be simulated. Then we start 3D thermal simulation of the battery. And so the most, not the most important, but most critical point is the thermal propagation and fire simulation. And Thomas Hülshorst will later show in his presentation more about the thermal propagation simulation and what we can do against thermal propagation. And at the end, like always, validation has to be done. This is also one load case. We simulated with the battery, or we usually simulate with battery. That's an electrical and thermal, a coupled electrical and thermal analysis. Here we find out where are the hotspots in the geometry, and with this simulation we can also define and also simulate countermeasures to reduce the risk for overheating in some parts of the battery. And also one example what we are doing here. This is so we offer material cards for adaptive manufacturing, starting with material testing. Then we make some substitute tests, some simulations, and at the end, on the macro level, we develop a homogeneous substitute model and develop the material cards to simulate adaptive manufactured parts which are used in a vehicle for all load cases. And that's also one example how to develop material cards. We can develop very simple material cards, but also highly sophisticated Gizmo 3D material cards with failure and which can be used then for crash simulation. Okay, what's the outlook, the perspective for the next year? What CRE will be in 5 years? What we think multidisciplinary optimization will be a topic for the next years. So to simulate the conflict between NVH and crash, which is a typical conflict in structural development, and we together with these simulation models, we can find the trade-off between the two disciplines much earlier than we have to do it now with always ping pong between the CRE and the crash and simulation engineers. We will have parametric ANSA models in the future, also in the very early phase. It's a very good tool to build up some parametric models. And in combination with this model, optimization is then much faster and much easier to handle than it is now. What we call, also one thing, we think, what will be occur in the future, 150% models. So you have the complete model and the complete BOM of a model and all derivatives in ANSA, for example, and then by pressing a button, you will the model for your derivative or for your version of the vehicle and your engine of the vehicle then will be assembled. And last but not least, water management and corrosion simulation will also be part of the simulation in the future. You see here 2 examples from water management and e-coating. What we have done here is water simulation. So it's the HVAC input, and here the behavior of the water out of the vehicle in driving in heavy rain fits to the current situation here, is simulated. And you see what's the water flow into the HVAC intake in front before the first vehicle or the first prototype is ready, and you can optimize the behavior. But there are other things which can be simulated with water management technologies. So it's general the simulation of water courses, the A-pillar overflow, the HVAC inlet and drainage, what we have seen here, water fording, and the water drop while opening the door. It's also a comfort topic for many vehicles that can be simulated very early phases. And another new technology or new CRE methodology is a simulation of e-coating. Also in very early phases before any part is pressed, and this can save a lot of money for the production planning. So you see the distribution of the e-coating in the vehicle. It can be identified very early in which areas of the vehicle or of the body in white the e-coating is not enough, and the complete structure, the holes, and so on can be optimized, and also in a very early phase. And last but not least, I mentioned before, one thing which also is under under development, simulation really is corrosion simulation. So many institutes are developing now technologies to simulate the corrosion of a body in white, and at the end you will get very early results where the first rust will occur, and also can identify methods and technologies to prevent that in a very early phase. So that was the end of my presentation. Thank you very much, and now I'm open for questions.
Dankeschön, Mr. Michael Hogg.
I step down, then I hear it better because you hear nothing behind of this loudspeaker. That's something which should be optimized by our acoustic engineers.
Thank you so much, sir. I hope that this vehicle man of FEV has really amazed us on the topic.
I have a question.
So open to the audience. You can ask the questions if any.
Yeah, can you hear me? Yeah, so my question is like this side pole impact. So is it part of any regulation or like that NCAP ratings or anything as of now?
Yes, it is. It's of course NCAP rating, and I think it's also now in Europe a legal requirement. Yeah, it has to be fulfilled. And if you want to, for NCAP rating, it's absolutely mandatory. Okay. And that's one part. On the other side, it's a critical load pace in real life. Okay. So you should take care about that.
And see, this is for passenger vehicles. For commercial vehicle like buses, the battery is kept in the roof. So there also maybe some special cases may have to be considered. So do you have any thoughts on that?
I think the rollover is critical. If you have, of course, if you have the batteries in the roof, so the ECER66 has to be taken into account. But for many trucks, heavy commercial vehicles, the batteries are somewhere in the chassis, yeah? And there are no legal requirements for that. And we have seen now many solutions which, from my perspective, are critical. Yeah? And I'm pretty sure that we have to develop in the future technology also to prevent an impact in batteries in commercial vehicles.
Okay. One more question is that I think you have see, vehicle dynamics is not part of these simulations. You have not shown any vehicle dynamics.
It is, but I could not show every kind of simulation.
Okay.
Vehicle dynamics is of course a part of our
because the load distribution is one of the very important part of
course, yeah.
basic design.
Yeah. Therefore, we need, of course, tests on the proving ground as well as simulations on the virtual proving ground in an early phase.
Yeah, my name is Prasanna from Tata Motors. I have 2 points. You showed the simulation on aerodynamics, and improvement shown is around 42 kilometers, range improvement. So is it simulated result or it is validated also, physical, or what is the correlation between the?
So the CD value is validated.
Okay.
But the correlation between improvement of the CD value and the range is coming from the simulation, from the range simulation. Yeah.
Okay. Second point is you showed something related to HVAC. So are you talking about the fresh air intake, the condensate and this one what you are showing there in the HVAC simulation? I think it is linked to the fresh air intake you are talking about, where the rainwater is entering. The channel you showed.
Yeah.
So they are related to fresh air intake. Am I right?
It was the HVAC intake, but
maybe
area.
fresh air intake. Yeah.
Yeah, exactly. Yeah.
Okay. Thank you.
Thank you, Michael. Very interesting talk and a lot of good simulations. I have few questions, but I'll start only with 1 or 2 and we can have offline conversations. So a follow-up on the side bolt crash test. Are there any simulation solutions for underbody protections, especially for the BEV vehicle? So to simulate the gravel bombardment test or underbody bollard penetration test?
Yes, so that's what the thing Bernd showed before. This is a severe problem for many BEVs, and we have, of course, simulation method. It's a kind of impact, yeah. You have to simulate. And we also have the possibility to test that in Aachen, in our test center. We have a special test bed where we can throw every kind of impactor to the battery, to the lower side of the battery with up to 120 kilometers. Yeah. And in parallel, we simulate and also validate our simulation with this test bed.
But also there is a standard for the battery penetration test, exclusively
Yes,
at the
yes.
battery level.
Yeah. So
if you
that's
can
why-
ensure that, that is the worst case scenario. So if you ensure that, automatically it will taken care in the vehicle.
Right.
But
So
certainly, yeah.
from the battery development side, there are norms for gravel bombardment tests and everything. I was just curious whether we have simulation solutions for that
But
also.
for example, the towing hook is not
Yeah,
in any
towing hook
regulation,
is not.
but it's from real life, yeah?
Right.
And you should simulate it
Right.
if you want to prevent accidents like that.
Sure. Just one more question. We hear a lot of difficulties or a lot of talk about EMC, EMI issues at the vehicle level. So do you think there could be solutions, simulation solutions to predict early on the EMC, EMI behavior before going to the development phase and the testing phase?
So to be honest, I'm coming more from the structural side of simulation. Please take this question and ask Dr. Thomas Hülshast in the afternoon, and he can answer this question. Yeah.
Thank you. Thank you so much, sir.
Michael?
And we can definitely take more questions in the break. So,
Michael, one question.
moving ahead, before we begin with our next speaker, let's have a small quiz again. So, a quick question to all of you.
Are you ready? Just checking if someone is choosing. Okay.
Yeah. So, the question is, which battery-related policy was rolled out by the government of India in the last quarter? Yes, we can raise the hands.
Battery swapping.
It's really very correct. Yes.
A
Congrats,
huge round
sir.
of applause for
A
Mr.
round of
Chandan.
applause for sir. Okay, so moving ahead. Now I would like to invite Mr. Dietrich Thoss, Group Vice President, Program Management, FEV Group, Stuttgart. He did his graduation from Mechanical Engineering, Munich, and is having more than 30 years of experience in vehicle development. Joining him will be Mr. Sachin Wagh, Chief Engineer, Vehicle and New Energy Powertrain at FEV India, cross-functional leader having an experience of more than 20 years in automotive. So please welcome Mr. Dietrich Thoss and Mr. Sachin Wagh, who will enrich us on ICE to BEV conversion.
Hello, do you hear me? Hello? Oh, perfect. So you see, we try all different ways to speak to you, from the standing microphone to the holding, and now we try this to be a little bit more flexible here on the stage. Thank you very much for the introduction, also in German, and also thank you for your patience. Listen to our presentations here. Before we come to the topic of the case study, I want to go a little bit on a higher level what we are doing in FEV with the development process. So please give me some minutes before we come to the case study to talk about that. So FVDP is standing for FEV Vehicle Development Process. So you might ask why an ESP, an engineering service provider, why do you need an, thank you. Why do you need, for a complete vehicle development process? You work for an OEM, he has his processes. Yeah, I think I have two examples. Around about 2 years ago, we started a complete vehicle development program with a customer who had at that time 10 people. So for sure, he had no process. He said, okay, FEV, I tell you what I want to have, what kind of vehicle I want to have. I tell you some of the range of the vehicle. I tell you the cost of the vehicle. But at the moment, I don't have more. Use your processes, use your tools, and then part by part, we will adapt, we will ramp up our people, and we will step in. And Another example for that, in the next 2 to 3 months, we will start with another customer, a project, and this customer has 40 people at the moment. So that is the reason why some years ago we said, okay, we need our own vehicle development process to support also these customers. But it's not a one-way road. We had half a year ago a very well-known OEM in Germany. He said, please, FEV, quote for this special car, but quote with your process. You know our very enhanced processes in our company, but this car has to be 30% faster on the market. So please tell us, what is your process? What is your way to speed up time? And yeah, don't use our process. So I think with every project we do together with our customers, we learn, we have a big lessons learned database now, and we change and adapt our processes. Yeah, I don't want to go into details now. I think here's so much expertise in the room. What are the main points? For sure, you need to have a process. You need gate checklists. You need a project organization. I will come a little bit later to that as well. But for sure, it is not one process fits all. Or every project needs an adaptation, and later in the ICE to BEV conversion, we will talk about that. And for sure, you need role descriptions. Not only role descriptions for FEV people to know what they have to do for the customer, but also to adapt to the customer and see, do we have the same understanding? What is our role? What will be your role? I come to that later as well, a little bit more into detail. And a meeting landscape, for sure. Yeah? When do we come together? In which way we come together? Which people work in which way together? Also here, I don't want to step into details, but yeah, for sure you have the engineering phases. Every customer has a little bit a different naming. We have our gates, and we have the major milestones. But this is on an extremely high level. If you go a little bit more down, we have a description for all, still on a high level, for all things which have to be delivered and done in a phase until a gate. To keep the time today, I don't go the next step, because at the moment we have round about 2,000 deliverables for the gates in a complete vehicle development process. And all these deliverables somehow have interdependencies. So someone needs something from another party to do his job and back and forth. So this goes down in a very, very detailed description how to develop a complete vehicle. And for sure, you can use that also for an ICE to BEV conversion. For sure, some things you will not need from these deliverables, but maybe 50% you will need. When we talk about why do we have our own vehicle development process, it's also easier for us to align with our customers, which every customer has a little bit another naming. But for us and for our people, it's also easier to see, okay, if a customer talks about PC, it is CA in our language, in our development process. You saw this slide before. You not only need processes, you need people to follow these processes and on the other side, enhance and improve the processes. So you have to give the people a structure to work together. And this is a structure we brought into our projects 2 years ago, roundabout. And I talked about another complete vehicle project coming up in the next 2 months. The structure will already look different. Because we talked about how fast everything changes in the industry. Electrification, software-defined vehicle. We always have to adapt how we work together. And we cannot say, okay, we have now one structure, one organizational chart for a complete vehicle, and this is now fitting for the next 10 years. Not working. So you have always to look, what is the customer needs? What is in the technology working? What do you have to change in your deliverables, in your way you work together? I think what also is changing for us, when we in the past discussed about what we do, we were mostly on this side here. So the left side is the side of the engineering. But But more and more, when we get, as an engineering service provider, more responsibility from our customers, the customer also wants us, we call it, to manage the interface functions. So what call we interface functions? The product definition, the process management, manufacturing engineering, homologation, lifetime cost after sales marketing. So more and more customers want to have this out of one hand, also us to manage it, to coordinate it. For sure, there will be a lot of input from the customer side, but we have to integrate, we have to bring it all together. And what I showed you before is the project organization, but you also have to see that your, we call it the line organization, is fitting to the project organization. So we can very easily taking people out of our specialist areas, out of the lines, into a specific customer project. So this has also to be somehow adapted to each other. Processes, people to work in processes, for sure you need tools as well. And clearly, if we work together with an experienced OEM, here a lot of people from Tata are sitting here, for sure we use the processes our customer wants us to use. Very, very clear. But as I said before, we have a lot of customers who say we don't have established processes, or maybe we want to do something different. We want to learn from your experience. You work together with many OEMs, so maybe you have some ideas about different tools. And also we have a tool landscape, which tool we use, or what is our preferred tool to use in these kind of complete vehicle development processes. Yeah, I talked about the meeting landscape. I think somehow basic. I don't want to spend too much time on that. Yeah, there's not one development process and plan. For sure you have different ways. So you have kind of all new. All new means you have a new vehicle, you have a new powertrain, everything is new. For sure you have longer timelines. We have some estimates on the right side, but please don't take them as granted, because there's no area in the vehicle development where is less light than in the time someone develops a vehicle. So I hear people saying, oh, I do it in 20 months, yeah, a complete vehicle. The first question I ask is, when do you start to count the time, and when do you stop the time? Because there's a lot of different ways to discuss about that. So it's only a rough estimation on the right side, what time you need for that. Yeah, for sure you have powertrain update much faster. So you have a vehicle which is already existing, you need a new powerhead, a new powertrain. The next one is the new top hat, mid-cycle enhancement, annual update. So for sure, for every of these, you have shorter processes coming from all new. So yeah, that was hopefully not too long with processes. I don't know how many engineers are sitting here. Normally engineers are not so keen with processes, so they say, oh, let me my freedom, I want to develop my car. But yeah, processes are needed. I think everybody knows. Yeah, in the example, Sachin and me want to introduce you, somehow it is in this area of powertrain update, this example ICE to BEV. So for sure, why do you do an ICE to BEV conversion? You want to save time, you want to save money. So time to market is crucial in many areas, and for sure cost is crucial. But it's not only that you save some development costs, you also save costs in your factory, where you can use for the vehicle, for example, you can use the same processes, the same tools. But you also save time in the workshops later in the after service, yeah? If you don't do everything new. The first thing, and this is a real life example, so I took some slides out of that, not too many, but some. Yeah, the first thing what you have to do when you have a kind of organization in the project, you have to look, okay, what is the customer doing? What is FEV doing? What are third parties doing, which have to be integrated into the process? And yeah, this is, as I said, this is an example. What we took over from FEV, what the client was taking over, and where did we have a common ground where we took the responsibility, both of us. There were very strict boundaries in this project. For sure there's everything possible or nothing is impossible, but in this project there were very, very, very tough boundaries. So they didn't want to have any modification of the electrical powertrain system. And they wanted to have a really minimized the modification on the base vehicle. So very, very tough restrictions in this example, in this project. And also this here is only one example of many we could choose for today's presentation. So here it was for the feasibility phase, and what we do at the end on a detailed level, but this is now the highest level for the top management. We make a kind of evaluation. Where are we after the feasibility phase? So in this case, we said, okay, positive feasibility phase. So we see that that generally you can do it. But as you see also on the traffic lights, and I don't know if in India green, yellow, and red is the same. So red for us is critical, or was critical in this process. Green was, yeah, it's fine. But for sure, after the feasibility phase, you have a lot of things which you have to still work on. And actually, these kind of high aggregate top management slides we do after every bigger gate for our customer. And for sure, in the weekly meetings, we discuss about where are the biggest risks, where do we have to work on.
Yeah.
Yeah. And then I want to hand over to Sachin. Thank you for helping me and joining here in this presentation.
Am I audible? Yeah. So this is very important aspect, BEV cost scenario, because most of the European or Western world OEMs has declared that they want to stop diesel production from this year. They want to stop entire IC engine production from that year. So everybody, we know that there are all strategic discussions and announcements been done. But for India being a market, where to start? Because we are being almost 75 to 85% of the vehicles being sold as A and A plus segment cars. So we are very cost sensitive. So what is the best approach to enter into this market? Is it to develop the new platform and spending millions of dollars into that? Or should we go, our existing vehicles are there, convert it into the BEV and take the advantage of early to the market, number one. Number two, 85% high confidence on all the attributes or aggregates, which has already been designed for the ICE vehicle. Let's say. And third is how proportionately we are putting money into the development, so that the proposition of the vehicle in the marketplace or with respect to the competition, we are offering two vehicles. One is with ICE and one is BEV. So we can, very sweet spots can be identified into the respective market segment and with respective vehicle segment. So that is how the cost scenario is very important. I think Alex, my colleague, has given very nice information in the morning. So if you can look at that, the battery pricing, everybody is talking about when the battery pricing will really come down and where will be the trade-off really that these are the A segment, A plus segment cars can be affordable to the most of the populations of the country. And that is all the projections, and India always has broken all these predictions. We are always couple of years ahead, or we are always couple of years, or maybe 2-3 years before all the predictions. And that is how we are looking at it. These are the battery prices, how we are going to coming down based on the moment electrifications are gathering all across the globe. So that will have a mass impact for the reduction in the cost. This is one of the illustrations, we did it. So where will be the trade-off? Why diesel cars should go away first? When there will be trade-off? When gasoline cars will have a trade-off with respect to electric vehicles. So we studied this, we looked at the typical, these are DMC, direct material cost or BOM cost. It's not sellable cost of the vehicle. And we looked at that, sorry. Yeah, so we looked at that, where will be the diesel cost currently, DMC, gasoline DMC and EV DMC. If we can look at like-to-like comparison for the features, functionalities and the same segment of the car. And how that will be progressive currently with respect to the diesel cars, if we have to meet the CO2 targets, CAFE norms and further technologies to be added upon it, how that will grow gradually. Just before BS 6.1, our diesel car to gasoline car difference was typically 60,000 to 80,000 rupees. Now if you can look at like-to-like, it has gone to more than 150,000 to 200,000 rupees. So that is how the differentiation has come up. And now where will be the trade-off? And this is the sweet spot. The gasoline or diesel likely to be with the battery 2023, 2024, the battery cost, BEV cost and diesel cost, vehicle cost will be the same. And for gasoline, it will be 2027. So who will be the competitor for EV? So gasoline vehicles, and that is the best to convert gasoline into the diesel. This is all the illustration been made. And how operating economy, which is also very important for us. So if you can look at gasoline prices currently in India, diesel, and the per unit, if you charge vehicle at your home, not at the charging infrastructure, but at home, 10 rupees. So the operating cost for 250 kilometer, what will be this? So it's a very been made, so it's a complete cost scenario, is a total cost of ownership of the vehicle. It's not only the cost of making the vehicle, but as end customer, what will be the trade-off when he will recover the money he's spending today, 2.5 lakh rupees or 4 lakh rupees, currently maximum than the current ICE or ICE vehicles. Yeah, then when we are looking into the BEV, what are the PMXUs basically? Because what is the advantage we are looking at it that the development cost should be 1/5, 1/6 or 1/10 of the current new platform development. Because your platform is already developed, your vehicle is already there, so you can always look at that with given slight differentiation. You can place two vehicles in the marketplace. One is ICE vehicle, one is electric vehicle. So the PMXU strategy, it is basically commonality strategy. So P for is as it is carryover from the existing vehicle. M is as it is, but slight modifications in the toolings or maybe little investments. X is the, you can develop for this vehicle, but can be utilized for the subsequent product in the future. And U should be the unique product exclusively developed for this vehicle. So PMXU strategy is very important here. So it is depending upon OEM to OEM. When we are looking at it, is it should be 60% carryover, 70% carryover, that always can be debatable. How you would like to place this vehicle in the market. So this is the typical carryover strategies. What are the components are changing? Powertrain, chassis, body and trims, and E&E. So these are all been in detail. If you can look at new part list, modified part list. If you go into the more detail, typically there are 400 to 500 component level changes to be done, either as a new, either as a modified, or either as the completely with the for the future developments. So this chart is very important. That is based on the part count also, and that is based on the costing associated with the each part. So PMX you can talk about in the both terms, the number of part counts and the cost of the BOM cost of the vehicle. Yeah, so typically any chief engineer or any vehicle integration engineer always look at that, what is the add delete list for me. So if you can look at what is getting deleted from this existing vehicle and what is getting added from this vehicle. So we also category can look at it, the faster time what my colleague District has come out, timeline of 30 to 36 months, or that again depend, are you taking the existing battery or are you taking the off-the-shelf EDU and all. So that timeline can always be debated. But when we are looking at it, off-the-shelf or carryover from somewhere. And this is how we come up with the what changes we are making as a delete and what has been the addition in the vehicle. Yeah. So another aspect is when if you can look at the, I don't know, you'll be able to see it, but typically there's a 25% weight increase because of the addition of the battery. Because battery is costing around, or electrification costing 50% or 60% of the cost in the total vehicle, and also in the weight, it costs around 20 to 25% weight into the weight of the vehicle. So when it is getting such weight is added, so who is getting sufferer? Which are the subsystem which has to be looked at from this weight addition point of view? So this is very important aspect, because what is the curve weight, what is the GVW, what is actually driving cycle weight, and all these things are required at the early stage of the program, so that we can, there is a topic also in this, so that we can battery sizing, EDU specification finalization are going to important here. Yeah, so this is the important aspect. I think one of the friend has asked this question, why not vehicle dynamics? So I thought I'll reserve this topic because we've seen all the presentation. We catered all the information for EVs into respective presentation. So I cover only the vehicle dynamic aspect of it, because the weight additions, so most sufferer will be the chassis system, where we have to take care of it. And which is going to be the impact is the all vehicle dynamic performance, ride, handling, all has to be taken care here. So this is the typical V. So when we are looking at it, looking at the attribute level target, and how we are cascading to the component and part level, and then how we are going into the validation level. So the typical we follow it into all the system level changes which are associated for the BEV. Yeah. So key drivers. Which are the key drivers? Electric vehicles, new architecture. So there are also topic being discussed. So cell to pack, module to pack, or directly module and directly pack to be integrated with the body. So all this. So how the architectural changes we would like to do it. So if it is a BEV, I think cell to pack is not possible, because there will be many changes even on the manufacturing line also. So for BEV, ICE to BEV, it is only we can go for cell to, we make a module to pack or cell to pack, but as a separate unit which is getting integrated under body. Yes, and that is posing the challenge for the ride and handling. So what are the ways and means to tweak to at least achieve the performance of existing ICE vehicle? Okay. Then low energy consumption targets. Obviously, now the prices are so high. So how much I should put it up in the battery? And should I reduce my weights? Should I go for high-end technology material so that my weight can reduce? But the battery capacity can be optimal so that give the targeted vehicle range. So this is also one of the very important low energy consumption. Also putting. And next, ADAS. I think Alex has given the very nice landscape, and India market is also following up all ADAS now, ADAS levels. So that is optimization or integration of these ADAS features into this new, old, I will not say old architecture of the vehicle for electrification point of view, but the existing vehicle. So that challenge we have to handle it. So which are the key driver basically? So if you can look at similar vehicle dynamics, because nobody will like to have a vehicle inferior compared to ICE vehicle. Okay, so we have to first and foremost important is that all the attributes, positioning, what we did it has to be matched with the current BEV conversion. And with that, when we are matching it, we should also identify what is the USP of my EV. So that also another challenge we have to handle. Increase vehicle mass, then change weight bias. So typically in IC engine, 60 to 65% at front and 35% or 40% at the rear. But how we are placing the battery, how we are going to bridge this. If we make the 70-30 or maybe 50-50, so this is all trade-off needs to be found out for the weight balance. Center of gravity height, because you are putting maximum mass there. So from dynamics point of view, it is nice, but that also going to reduce your ground clearance. But to upgrade that ground clearance to the current ICE, then you have to take most of the hard points has to be taken care into the new scenario of the vehicles for the suspension. Then increased drive torque. If you can look at all the current IC engine vehicles, we were very happy when we came down 0 to 100 under 10 seconds. Okay, but right now people are making announcement. I want 0 to 100 in 3 seconds, in 5 seconds, in 6 seconds, because there is a lot of torque is available in the e-motors. And that they want to capitalize as one of the USP that my vehicle is the fastest vehicle in the marketplace. So that also we have to handle through this dynamics aspect. And package implication, obviously, yes, where we are packaging battery and also the safety aspects and regulations coming on the vehicle side for it. And carryover part strategy. As I said that it can be go from 60% to 85%. It depends upon OEM to OEM how we are handling it. But what is impact on chassis is all suspension, concept, KNC, characteristics, dynamics behavior, then tuning. So can we tune if there is only 100, 150 kg weight increase overall, or distribution maybe 70, 30 or like this. So there is a tuning can possible, spring stiffness can be optimized, so that also has come into the play. Also EPAS and ESC, electronic stability. So that has to be recalibrated because of the new weight distribution strategies. Okay? And always we should look at that we cannot change the tools. So we lost the advantage of having the carryover. So we have to look at what modifications I am doing into this system. So I should not end up in developing the new system. So the minimal change and minimal development has to be done here. Yeah. So this is all been looked at from the overall this, but at the end of the day, we have to also look at battery sizing. The India being a market, the first vehicle been launched with the 17.5 kilowatt hour. Earlier there was also one of the vehicle with small, very small car that was very low battery size, I think 15 kilowatt. but 17.5 kilowatt. Then later people came up with 30 kilowatt. Now it is 45 kilowatt also in the marketplace, 40 kilowatt. How we size the battery? There is no limit. What is the usable range we want it? 250 kilowatt hour, 250 kilometer, 300 kilometer. That is also becoming the USP. But how we are going to fix the battery size? So this is the available. First, in the structure itself, we have to define where I am going to package the battery. And based on that, what is the available place for me? That is one aspect from the structure point of view. But on the battery side, cells, modules, what are the chemistry, what I am going to use it, how energy densities and how I am going to, how I am going to use it in this year. So these are all sizing approaches. So we have to fix what is the space available for me. It's not that today if I can able to package 60 kilowatt hour battery, does it mean that I can give the 60 kilowatt hour battery? No. There will be always, if we have to make the longevity of that vehicle into the marketplace, I can start with 40 kilowatt hour and subsequently I can add on the battery capacities so that I can also exciting the marketplace with the higher ranges and the similar vehicles. So this is all based on this. So if I done these calculations like 1.2 meter versus 1.45 width, I can package 45 to 50 kilowatt hour battery with available cells and the chemistry available. But now what are the vehicle parameters? I think somebody has asked what is the CD value and how it is impact. So we did a lot of significant study on this. So what is the curve weight of the vehicle, what is NEDC, gross weight, aerodynamic vehicle, tire rolling resistance, and how these parameters, frontal area of the car, which is styling driven completely, so that then LV accessories, auxiliaries, how much weight their energy they are taking out, dynamic radius and rear capacity of the EDU. So these are all the parameters, and we did completely study, sensitivity study. If I can have the curve weight, if 0.27 is a CD, 0.28 is a CD, tire rolling resistance 7, 8, 8.5 like this, battery modules with the usable energy, battery total energy, usable energy, and we predict the range, how much I can go and where I have to stop. Range can go for the similar vehicle in the given space to 735 to 813, another 621 to 650, and next one is the 555 to 600. So it's called what in the given space how much battery I can package. Okay. So now coming to this, after doing this sensitivity analysis, so we also did how this sensitivity governs this. So if you can look at LV auxiliaries, there's always been debate in the, all our E&E guys will always curse, especially from the OEM place. There will be always pressure from this to reduce the wattages. And from the beginning when they define the architecture. So if you reduce the load of the auxiliaries plus minus 50 watt, there's a potential to increase the range by 10 kilometer. Okay? Then improvement in depth of discharge from 92% to 94%. There's a 15 kilometer range advantage we can get it. Okay? Then, but that does not mean that all the cell chemistries are at the current stage are able to do this. So that is also a trade-off we have to find out. Tire rolling resistance plus minus 5. Currently in India market, it's 8.5 or 8.5 to 9 is available. The moment you go on lower and lower side, considering Indian road conditions, especially for the countryside, so there is always a curb strike and you can do catastrophic failure of the, yes. So that can be a 14 kilometer, and then CD improvement 0.01 comes to this 7 kilometer plus minus if you can. So now 0.6 what Michael has told, 0.06 has come to 42 kilometer. This also, this is done for another vehicle analysis. And most important, reducing the gearing ratio. So drivability, max speed, how we can optimize. So there will be 15 kilometer range. So in totality, we can always look at that where I have to be. Should I spend money on the battery to give the maximum range, or should I work around these parameters where I can reduce the cost? That is how the trade-off and battery size can be found out. This is the from last slide from my side. This is from the Indian context. What are the regulations for ICE to BEV? Yes, almost 85 to 90% regulation your existing vehicle is meeting. But on top of it, how many regulations, which most of the guys must be aware, but I thought I can again rebrush these things. So these are the regulatory requirements in the CMVR regulation is available from ICE to BEV. Yeah, so thank you. Yeah, thank you.
Thank you so much, sir. Open to the audience if anyone wants to ask any question.
Hello.
Yeah, hi, Dietrich. From here.
Sorry.
Yeah, Ashish. So nice to see your slides along with Sachin. One question is how to optimize or balance the situation if client is asking project to be delivered in 6 to 8 months, but as per the FEDP, the timeline goes or project time scale goes till 12 or 14 months.
Yeah, that's why I said this is only a rough number. So every project is a little bit different. So I think the first approach, if you have to speed up and if you have to bring the car faster to the market, take off-the-shelf components. So reduce the new development even more. Yeah, and we have very good examples and experiences really looking for suppliers who have something on the shelf, little modification only to be done, and bringing it to the vehicle. So I think that is, from a maturity point of view, from a cost point of view, from a timing point of view, don't develop something new if you can find it somewhere on the shelf. I think that is the best way to save time and to fit to the customer's approach.
Yeah, great. Thanks.
Any other question? Okay. So thank you so much, Mr. Dietrich Thos and Mr. Sachin Wah.
1 minute, one question is there.
Okay.
Hello, my name is Mahendra from Tata Motors. Actually, you have mentioned about all the analysis about passenger vehicles regarding this changeover from gasoline to EV is most feasible option. What about commercial vehicle? Any case study you have done for the commercial vehicles? How we can plan for migration, or which can be the sweet spot of the GW where we can switch over to EV for this.
Sorry, see, for commercial vehicles, EV is not the only option, okay, as of now. I think the moment EV has startup, people are starting with hydrogens also. Okay, so this kind of study, the industry has to work at least for 5 years more. What will be the sweet spot for the commercial vehicles when people can give the big announcement, I want to stop it? Because the hydrogen economy globally will boost in this entire decade is the hydrogen economy. And maybe for commercial vehicle, focus will change. So it is too early to predict for the commercial vehicle where is the sweet spot and when it will be. It is too early to predict.
Yeah, I can talk out of or two projects. I think it's very much dependent also for the commercial or light commercial vehicles. What is the usage? Is it a last mile, I say not last mile, but maybe, is it a last mile delivery for the city? Maybe there's another approach, not maybe, there is another approach. Yeah? What is the main usage of the car? I would say for a city delivery van, for sure battery. Yeah? But we have another customer just at the same time of our development now, who said, okay, I need but a vehicle which goes highway. Yeah? Most of the usage of the vehicle will be highway, and also the infrastructure is not very good in our country or in the countries. And we develop now a hydrogen or a fuel cell vehicle for him. So at the moment there's no yes or no. For sure, battery is at the moment in all minds, but there is usage for hydrogen. I'm very convinced. There is a lot of different options to
Yes, we agree. Actually, I'm Chandrasekhar from Tata Motors. We agree that in commercial the batteries presently is not being used. But Chinese is very aggressive, and they have come with the now tippers also. The off-road tippers, 40 tons with the electric tippers in India. They launch in Hyderabad.
Mm-hmm.
So there is a threatening is there from China completely for the in commercials, the complete battery vehicles till the hydrogen is being there. First of all. Secondly, actually, apart from the trucks or the goods carrier vehicle, in passenger vehicles like the vans, then public transport vehicles like buses and all, is already the battery electric vehicles, and it is already popular in China more than 10 years, and now India it's more than 3 to 4 years. So what is basically what we are finding, your experience in the commercial vehicles is not getting captured here.
Okay.
So we want a confidence whether you are there in the commercials or not.
Mm. I'm not 100% sure if I got everything, but
Sachin understands.
Yeah.
Sachin understands.
I understand your question. See what happens, it is not there to vehicle technologies are same. when we are talking any new technologies, the applications are changing.
No, no, no. Basically, the applications are changing, but it's a totally different game. It's conceptual for battery technology, architecture, and the challenges which are facing for last 4 or 5 years are very big.
See, now I have not unveiled that platform. So we are developing a 6 to 9 meter very flexible commercial vehicle platform, which can take care of your existing ICE plus electric vehicle, plus electrification, plus fuel cells, plus pure hydrogens, all put together. And that's how I thought I will unveil today, but I have not done it, maybe in the next time. But it is not the question that as an organization, and so yes, we look at only technology. Application based always can be converged together with the you and me. If we can sit together, so application can always be worked out for this. And it's a strategic call. If the OEMs coming from the outside OEMs are coming and dominating the market, I think it's a strategy for the market scenario to be studied for the commercial vehicles. Yeah? So Alex, if you,
yeah, maybe one more comment. Yeah, I think the question is also, you cannot only look from a vehicle point of view, but you also need to take into consideration the infrastructure. So if you have the infrastructure ready, then there is maybe the higher competition between battery and fuel cell, or battery and hydrogen combustion engine. At the moment, I would say, especially when we look into Europe, up to now, and maybe with the Ukraine crisis, something is changing, but up to now, the investments have been made into the electric infrastructure, building up the charging points, building up high power charging at the highways for battery electric trucks also. So it's very costly to do this in parallel also for the hydrogen infrastructure. We will see maybe for dedicated application, maybe point A to point A, so kind of a depot truck that is not going from A to B and then to C. But if he is returning back to his depot, then hydrogen infrastructure can be built up, decentralized very easily, like we have today also for gas or for other diesel refueling stations, right? So I think we have to take both into consideration, the vehicle, the infrastructure, and also the application. So for example, when you have a truck, you need to look also what is the load I can put on the truck. Not only kilograms, but also volumetric. And if you have a lot of, for example, hydrogen tanks, that takes away a lot of the volume, then this is also not beneficial for the total cost of ownership for the truck to earn the money. So you need to look very specifically into the different use cases. On a bus application, completely different discussion compared to a long-haul truck, compared to a local city delivery truck. Yeah? So I think we really need to look into the specifics, and I think there's a place for every technology, but it has to fit. And this is, let's say, where we also support, together with our engineering colleagues, to make that fit, market, infrastructure, and the vehicle application.
Very true, thanks.
Yeah. And even without one company, so my former employee, Mercedes-Benz, and it's well known and publicized, they go both ways. So they develop fuel cell trucks and they develop electric trucks. So many companies go even both ways at the moment, for each application something else.
Yeah.
Hello. Yeah, I have a question extension to what we were discussing. It might be a little off the topic, what Mr. Alex was saying. And
Alex.
Yes, so we all are talking about development of e-vehicle or conversion from ICE to this battery electric vehicles. But we are not talking enough about the scrapping of how this scrapping will happen for the battery later on. Today we are struggling with the environmental pollution, and we are going from ICE to BV. But later on, of course, we have a big challenge coming forward in terms of scrapping the batteries also. So you are in the consulting space, and you are must be dealing with many other OEMs and other.
Yeah, I'll give.
Yeah, many other different agencies also. So what exactly at global level we are doing for this at the end?
Yeah, so first of all, you're absolutely right. So the battery recycling is of course a big headache, which also, let's say, the big OEMs are now tackling. Let's say next to, and I showed the slide with all the battery capacity being built up in Europe, if you remember on my presentation. Next to that, everybody is now thinking of how do I organize my battery recycling? Because, for example, in Europe, we have a regulation where I think minimum 90% of your battery needs to be recycled. So it's a huge headache to get that back in and do this in a very efficient and in the most environmental friendly way. So saving most of the energy as possible. And I think there is a lot of development. At the moment, we are kind of in the forward way to develop batteries, to develop battery electric vehicles. I think in the next 5 years, we will also work very hard to think about what can we do to improve the recycling of the batteries. And then there needs to be kind of a loop backward, because today we are only focusing on cost for the battery, then the energy density, and then of course safety, right? What we are forgetting is designing a battery for the sustainability point of view. How can I dismantle the battery? How basically can I take it out? How can I avoid, for example, certain adhesives that are difficult to get dismantled? Yeah? So I think there is a lot of research to be done, new technologies to be found, and also new tools to develop that we have a much more efficient recycling process. But one thing is for sure, we need to build up also all the recycling capabilities in the industry, because we must move away from just using virgin material to using recycled raw materials. Ideally we have a second life application for batteries, but this in some places I think is more wishful thinking. I think most of the OEMs are now going more towards the recycling of the batteries.
Just to extension of that, of course, right now it's quite premature to talk about the battery recycling, but now we have the very advanced technologies, and the OEMs are well equipped, and we have better technology what we had at the time of development of the ICE engine. And now, should it not be a responsibility of OEMs to start think about battery recycling?
That's what they do. That's what they do. I can only give you one example from Volkswagen. If you have a chance, you can go on their investor relation page. There's a talk on their battery day, and they also explain about what they are doing on the battery recycling. There was a recent post from Ola Kalenius from Mercedes-Benz. They announced their activities on battery recycling and the degree of recycling rates they want to achieve for the battery. So it's clearly on the agenda of the CEOs to think about the battery recycling, and they're making the investments, and there are also larger company consortia who are now developing the supply chain or the backward chain, so to speak, for getting back the batteries from the market. This is a midterm topic. You have to understand, first of all, in the next years we are developing the vehicles, we're bringing them into the market, then they will stay in the market for maybe 10 years, 15 years, and then we will see gradually ramping up the volume for recycled batteries. Yeah? So until then we have time to build up the infrastructure.
Thank you, everyone. We can really keep up with the conversation in the break as we are running short of time. So any other questions? We can engage with the speakers in the break too. So what a stupendous day till now. After hearing about different ways to fuel our cars, now let us fuel our body too. So I request all the guests to proceed towards the area where the lunch arrangements have been made. And let's meet again in an hour by around 2 p.m. So hope you all have a great lunch. Thank you.
We'd like to drive 250,000 kilometers safely and without major breakdowns. We always want to be safe when driving from point A to B. Also, in case of an accident,
project, we have achieved a CO2 reduction of 25%. The development of innovative battery systems is still facing major challenges. We have the race for higher energy densities. With this, it comes also the increased demand for safe battery systems, especially thermal propagation is here a problem. We have the availability of battery cells, the development of new chemistries, the need for testing and reduction of timing for the developments, as well as pack production. All these things need to be considered.
Hello. I request everyone to please gather in the hall. So that we can start the session. Hello. I request everyone to please come inside the hall so that we can proceed.
Check. 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 Hi, Mr. Isan Sharif, I want to check your sound. Can you just unmute yourself and speak something? Check. 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 Hi. Hi. Can you just check sound check? Check sound check. 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 One. Isan sir? Isan sir?
Hello. I request please come inside the hall so that we can start our session. Okay, for the time being, let's have another quiz. Just a quick refreshment for all of us. Can anybody tell in which year FEV group founded? And by whom?
Yes, there are
Two
quite a few
questions
hands
together.
raised.
Please raise your hand.
Yes, please raise your hands. Bit taller.
Year and the founder's name. Yeah.
1978 by Professor Franz Kissinger.
That's correct. Please give a round of applause.
A very quick another question. In which year did FEV India Technical Center inaugurated? 2006, yeah. Very well said. Technical Center. No. No. 2009. Thank you. Now I request Faguni, you please start the session.
Yes, welcome back everyone. I hope all enjoyed the delicious lunch. I hope all are refreshed for next sessions. So let's begin. Now let's welcome Mr. Michael Hogg, Mr. Hani Al-Kholi, and Mr. Ishan Sharif to enrich us on development of first Egyptian electric vehicle. Let's hear from them. I request all the speakers to please proceed towards the dais. So Mr. Hani will join us virtually. Yes, sir, you can begin.
Can you hear me? No, you can hear me. So good afternoon again. It's again me. This time I want to present you, together with our valued customer, the CEO of El Nasser Automotive, Mr. Hani Al-Kholi, and our partner regarding PLM solutions, Mr. Ehsan Sharif from Infocore. We want to present you our joint project, the development of the first Egyptian battery electrical vehicle. We divided our presentation in three parts. First of all, I show you the overall, the project scope and the background. Then Mr. Hani Al-Kholi informs us about the vehicle strategy in Egypt, some more information about Egypt, and also the brand El Nasser, which has a long time history, which I think is very interesting for also here in India. And last but not least, Mr. Ehsan Sharif gives us some information about the involvement of Infocore in terms of PLM solution and PLM development for project partner. Okay, this is here on this slide you see the business relationship between all three partners. Three partners in this case is let's say Team FEV, which exists from FEV itself as a lead contractor of El NASCO, and Infocore and EBZ as our partners for the different areas. El Nasser Automotive, and as an automotive manufacturing company from Egypt, and the vehicle OEM, which has to be sourced by El Nasser in cooperation with FEV. So the different tasks are, so of course El Nasser is a local manufacturing of the new vehicle, the first electrical vehicle in Egypt. El Nasser is responsible for the supply chain management of the localized parts which are produced in Egypt, and also for the distribution, sales and after sales, of course. FEV, or the FEV group, is responsible for, we are the general engineering partner for NASCO. We are supporting in product and manufacturing engineering, and we are the consultants for the overall business case for the complete project. And the vehicle OEM, he supplies us with the non-localized parts as a knockdown kit. They are providing us with the IP for the complete BOM. And of course, they give us technical support in the realization of the project. And here on this slide, a little bit more detailed, what's the scope of the FEV team. So we started with donor scouting and the support in the negotiation with donor scout OEM. Project management is our work scope. Styling, because we have a new top hat design for this vehicle. And product development as well as manufacturing engineering is in our working scope. Procurement, test, validation, support. All the tests will be performed in Egypt or in some countries in this area. And the product lifecycle management support is also part of our responsibility. Here, a little bit more detailed is the work scope or the work split between FEV on the left side, EBZ on the right side, and our partner Infocore. So FEV is responsible for the complete product development and the program management and the donor OEM selection. EBZ is responsible for the complete manufacturing engineering. We have our interface in the SE teams, and Infocore is supporting both parties and also another with the PLM system. Only one thing I want to show you, what is the process the structured process of FEV to select the donor OEM. So at the beginning, we have a very huge database with more than 250 vehicles available, and 250 battery electrical vehicles. And starting with these 250 vehicles, we have a process to filter, so vehicle type, segment, battery capacity, range, and so other topics where we filter. And so we have an initial, and of course the FEV judgment is also part, a very important part for the filtering of the first 30 vehicles, and then after this process, only 30 vehicles were left who would be suitable for that kind of for the Egyptian market. And after we selected these 30 vehicles, we did the next step. We selected the top 10 of it with a special assessment with a ranking. And after this ranking, I show later how it works, 3 out of 3 top vehicles were left. And with the help of the worldwide FEV network, we have very good relationships to nearly every OEM in the world. We started the negotiation process with these 3 candidates for donors or for vehicle support. This is only an example how our, after the selection of the 30 vehicles, we prepare a sheet where all the dimensions and the main specifications of the vehicles are available. This is only an example. One of the potential vehicles who could be a donor vehicle for production in Egypt. And also here we have a very detailed sheet where all the equipment and the features of the vehicle are shown. And this is the major document to select at the end the vehicle, because all the requirements of our customer then has to be fulfilled. And then after we have selected only 30 vehicles, we make this ranking with different points, so key vehicle specification, equipment and features, base price score, vehicle and powertrain quality, as well as OEM reliability and feasibility, KD feasibility. And after we made this process with a lot of experts, then we have finally a rating and could select the top 3 possible donor vehicles. And we established this process at FEV, not only for vehicles, we also could use it to select a donor platform, donor parts like batteries, and it's a process proven in many programs until now. So that was it from my side, and now I want to give the word to my valued customer, Mr. Hani El Kholi. Good afternoon. And please, you're muted. We cannot. Hello?
Can you hear me now?
Now we can hear you. Welcome.
Okay.
Good afternoon. Oh, good morning.
Good afternoon, ladies and gentlemen. It's my great honor actually to present our story. I hope it will success with full support coming from FEV as we are expecting. And they're of course supporting another company like Infocore and EBZ. Let me first introduce our factory. So our factory located south of Cairo by around 25 kilometers from Cairo. The total area is around 400,000 81 square meter, and the building or covered the building is around 100,055 square meter. So we established the company. We were established in actually in 1959. It's actually we have a long history with producing vehicle, but unfortunately all of that period was only a sampler for the vehicles. First, we have producing the different kinds of vehicles, including the heavy truck, buses, tractors, and of course passenger vehicles, all those four wheels. And we started with under umbrella of FAIR as a licensee. So we produced the vehicles. Then we have another deals and agreement with a German company and Yugoslavian company in 1964, 1966, 1970. And we completed, we continued producing till 2009. So it was the last production with Fiat. Then we discontinued our production with Fiat. So you can find the next slide here, slide number 12, different kind of our products. Since starting our production, it's very old shapes for Fiat, and sometimes we bring the CCD from Poland, like Bolognese, or coming from Yugoslavia as a passenger vehicles. Then for the next slide, in slide number 13, you can find that Egypt has a long history of free trade agreement with our neighboring countries in Europe or in Africa or Middle East. Till now, we have no effective free trade agreement actually, because we are not manufacturing our own car in Egypt. Then our company is main stakeholder is government. That means we are a state company. We in Egypt start to think how to renovate and to revive our factory, and based on the government initiative starting last year to go green and to electrify most of the vehicles inside Egypt usage in Egypt, including four-wheel driver, public transportation, two wheels, and also three wheels. So we started to think how to revive them. Accordingly, we have a long journey looking for who is the OEM partner to work with us and to utilize their networks and utilize their capabilities and technology to utilize the assembly, then localize some of parts manufacturing inside Egypt for the electric vehicles. So the number one, we of course scouted the important thing, which is the specification, and we selected it. Then we finalized it. So middle of the last year, we thought that it's will be a very good choice if we rely one of the trustable company who can support us for scouting the vehicles from all over the world and supporting technically their facility, their capability, in order to scout, then supporting how to style and engineering the vehicles, and also to preparing or renovate our production facility inside Egypt. So then we thought that we of course start to look for the best choice as a consultant and also a real partner for building our engineering capability, development, and also negotiate with the OEM for a best deal in order to find their parts, then to change and engineer the parts based on our needs. Finally, we found an FEV. So since about now 9 months or more than maybe, actually we have a deal with FEV. They are supporting a lot, and they are making all our service requirements as an owner actually for the project. It was a great actually supporting, and they give us a real hand as an ownership. This is very important and too much actually appreciated what we are doing now. Till now we are working day and night, I think, and every time I can find solutions, and this is a very important thing that whatsoever the problem I'm facing or roadblocks I'm facing, I found their real support and solutions.
Mr. Hani,
they also
Mr. Hani, one question. Can you reduce your background noise?
than the normal job like to preparing our factory, but also we are relying in EBZ as another partnership actually for production line setup, looking also at solutions, looking also for all details of feasibility study, and all things required for production. So including even
I asked Mr. Hani, can you reduce your background noise, please? It's very hard to understand here.
Oh. Can you hear me now? Hello?
I didn't hear you. Am I on the right page?
So now I am in page. Yes, I am now in page number 16. Hello, Michael?
We can hear you, yeah?
Yeah, okay. Page number 16.
Thank you.
Okay. Can I go on?
Ich verstehe es halt noch viel weniger.
I think you can continue, Mr. Hani. You can continue. I can hear you. Yes, I think so. Mr. Michael, you can hear Mr. Hani.
Okay. So, according to the initiative from the government to go green, so as I told that we launched our project, and we rely on FEV as a partner for that. They are giving us a real support and a real hand, and find all solutions for our project realizations. So one of the important things that the government started to take care of the preparing the infrastructure inside country for accepting the electric vehicles, like arranging some subsidy for the end customer, and starting to manufacturing the charging pipes inside company, and also starting to change some of the regulations and laws and also make some teaching and education for the customers how much the electric vehicle is involved. Back to the rear hand coming from FEV. So please move to. So I would like also to mention inside also 16 slide 16 that in order to satisfy all our needs actually we started now the journey of OEM agreement, and we are now about to finalizing our agreement with their sides and to find a bus, and finally we have an agreement with them. Simultaneously,
Ezan, can you mute, please?
FEV
Perhaps it's getting better.
already with our partner EVZ starting to establish the production facilities. Under all of that, both in order to also realize our management for the production facilities and also the product development parts. Also, we found that improve with the PLM system applications, including training for our engineers. We are preparing ourselves for that. Then we can assure some of the smooth and things starting for our productions. I hope that soon I can meet you again and giving you that we finally realize our dream to starting our first electric vehicles in Egypt by FEV support. Thank you, gentlemen.
Thank you, Mr. Hani. And then we continue with
Ezan.
We continue with Ezan.
Thank you, Michael. Can you hear me?
We can hear you.
Okay, so good afternoon to everyone in Incredible India. My name is Ehsan Sharif, greetings from Germany. I'm the managing director of company Infocore, and I'm here together with Mr. Hani and with Michael Hogue to tell you about this great story of the first electric vehicle in the Middle East region. And it's, for me, it's a big privilege because I strongly believe if you have to make money, you have to know how your customers make money. And this is what we did. We, as the first step, we were able to bring my favorite and favorite customers, NASCO and FEV together, as Mr. Hani mentioned. And NASCO was looking for the right engineering partner. So this was the first step. When it comes to electric vehicles, as you see on the screen, the speed at which now the market is demanding for a new vehicle to come is almost half of what a traditional company would do in the past. So to do this and to cover all the areas, for example, as you see on the screen, right from product portfolio engineering, going down to manufacturing, going down to procurement, and to bring all this together, you need very good solutions. And if you can, Michael, go to the next screen, the next slide, please. Thank you. So what we did is we first understood all those processes and did with a lot of experience we have in Infocore, especially on automotive, we brought them into a structure, running a lot of workshops together with FEV and NASCO. We could bring them into a structure, defining them in various phases, especially from planning, engineering, manufacturing, and execution perspective. And the next step, Michael, you go to the next slide, please. Thank you. So what we did is we brought all this together on Siemens platform. And I believe not many know, but Siemens is now probably one of the largest software developer in this field and one of the most successful in automotive industry. And Infocore is proudly partnered with Siemens digital industry software. We have been offering various solutions, especially in PLM space. We have NX to cover the CAD space and also the shop floor management system. And all this is running on Infoco developed template for automotive, which helps especially to develop and bring customers like NASCO very quickly into the market. Yeah, this is what is our main target. And Michael, if you go to the next slide, you can see what we have done is we have divided the project on three phases. The first phase is focused on design. This is where we are focusing on design, document management, engineering, data management. Most importantly, to get the first step, the start ready. So once this is done, now what we are working, which is very important for NASCO, is to collaborate with other partners. Yeah, this is how does NASCO will collaborate with FEV? How will they collaborate with their OEM partner? How will they collaborate with other suppliers? For this, we have the supplier collaboration and the design exchange platform, which we are working on. And when I also met His Excellency, the Minister of the department which NASCO is under, the main focus would be quality. Yeah, and this is the reason why in this phase we are also focusing a lot on quality as phase 2. In the next steps, we would then extend this more in the direction of making it a global car, especially by bringing substance compliance, which is really required if NASCO decides to go into another market, like, for example, Europe. So in a nutshell, we are bringing all these three phases together for NASCO and FEV. In fact, we are helping both of them together. Working with FEV for me is a great honor because it's I think one of the most agile automotive consulting, engineering consulting company. They are probably the first ones to bring this very complex systems on cloud. And Infoco is really privileged to have put all this engineering and manufacturing solutions on cloud for FEV, and we also will do the same for NASCO. So this is in a nutshell. Michael, if you go to the next slide, I think that's the conclusion. Yeah, so we are looking forward to bring this together and continue to help NASCO, FEV, and EPZ in building this digital twin for the electric vehicle. Thank you very much. We are open for any questions now.
So thank you, Mr. Hanis. Thank you, Özan. I apologize for the bad quality. But yeah, Mr. Hani, please mute. That was, I think, that was the main problem. Are you muted now? Are you muted? So, yeah, thank you. Now, if there are any questions, feel free to answer, to ask.
For sharing valuable words with us. Now let's have another quiz round. Now the first question is, what is the full form of FAME scheme that has been launched by Government of India? Please raise your hand. Go.
Ravindra here. It's faster adoption and manufacturing of e-vehicles.
Anybody else?
One word is missing in between.
Yeah, one word is missing.
Please tell the full form.
We will meet
not
after
just
this
hybrid.
conference, Ashish.
Faster adaptation and manufacturing of hybrid electrical vehicles.
Yeah, that's right. Thank you. Now the next question is, what is the full form of newly launched policy of BN-CAP? BN-CAP.
Bharat New Vehicle Assessment System. Sorry, Bharat New Car Assessment.
Yes, that's right. Thank you. Please give a huge round of applause. Now over to Sakshi and Faguni.
Hello everyone. Before we proceed, yes Sakshi. So Sakshi, I want to ask you something.
Yeah, tell me.
Do you own a smartphone?
What kind of question is this? Everyone has a smartphone. I can't live without.
Oh, great, yeah. So, when did you last update it?
What is its relevance now?
Tell me, when did you update your smartphone?
I had it online updated few weeks ago, but why?
Okay, and what about your car?
What about my car?
When did you update your car last?
Update my car? Like update the car system? Is it even possible?
Yes, it is.
But how?
Over there.
Over there? Can you please explain?
Yes, and not just update over the air, but a lot of new modified features will now be added to our cars due to this new domain SDV.
SDV? What's that?
SDV means Software Defined Vehicle. Though it's a novel topic, SDV is an emerging concept in the automotive world. And to familiarize the same, we have a very able and experienced Mr. Anand Bhange. Over to you, sir.
Mr. Anand Bhange, Head of Intelligent Mobility at FEV India. He possesses more than 25 years of experience in products, system architecture, innovation, development, standardization, and exploring technologies, software, and products in various vertical industries. He is going to enlighten us on factors relevant to next generation EE architecture. Please welcome Mr. Anand Bhange.
So, good afternoon all. I think we looked at mechanical world. In previous presentations, we also looked at a lot of battery or chemistry world. Now let's look at electronics and software world, which is also a very, very important aspect in today's vehicle. So we belongs to FEV which is a subsidiary within the FEV group, predominantly focusing on latest technologies like connected vehicle, ADAS, software, and that's where I am also going to talk about software-defined vehicle. So software-defined vehicle, it's a huge buzzword. Everybody is talking about it. All the OEMs are working on it. But nobody has, is it a dream or is it a reality? Nobody has those answers. And what we are trying to do within the FEV group, along with some of the partners, is to make that dream of software-defined vehicle into some reality, and while converting this, learning about this very new topic within the automotive world. So I think we will talk about overall things into starting with some background, why do we need this, and then we will go in terms of how we can solve some of the new upcoming requirements within the automotive world with the buzzword software-defined vehicle. Why do we need software-defined vehicle, or why do we need something which is very software-oriented? I think that's mainly because there are 4 areas the demands within the automotive is increasing. And all the areas are increasing very rapidly, so be it user demands, so user needs latest functions. They need all the functions in quick time, in lesser cost. OEM needs cost reduction, faster time to market. The technology demand, the technology is kind of begins its cycles, and in 2-3 years, the technology itself becomes absolute. So if we have a traditional automotive development cycle of 3 to 4 years, by the time technology itself will be absolute and we will have a very new technology. So we also need to look at what is the current technology and keep changing based on the technology requirements. And then also there are new functions being added to the vehicle itself. And all these functions are very complex, interdependent. So how do we solve all 4 areas demands into one possible solution? So I think we are talking about demands. So how do we, at a very gross level, how do we solve this question? I think the questions are in terms of we still need all functions. We still need to maintain safety and security of the vehicle, manage all the complexity of the functions that are being demanded, and then also come out with the product in a very lesser time frame. Because again, there is a competition and everything. There are also, because of reducing time frame pressure, there are also demands in terms of how do we develop things in parallel. So how do we do distributed development? So looking at all these questions, what are the solutions? If I look at all those 5 pillars or 5 answers that we are looking at, there are these buzzwords across the industry, not only just in automotive, but these buzzwords are kind of first level answers to what we are trying to solve the problems. If I go more detail in terms of taking those buzzwords and looking at what are the technologies, how other domains, non-automotive domains, have already solved these problems. So some of these problems, for example, in cloud or IT world, all of them are already a solved problem. Of course, what we are trying to do is bring that learnings, and now we are trying to integrate the complexity of automotive in this. So which means we are not only adapting the technology from IT world, but still get it matured enough to solve the automotive problems. And that's where we are still looking at these buzzwords, but we still need a way in terms of delivering an architecture which is suitable for automotive environment. So if you look at typical architectural flow, it starts with hardware. I'm purely talking from the E systems of the automotive. So it starts with hardware. Now we are bringing some virtualization, mainly because we want to integrate the hardware to reduce the overall development time period. So we must consolidate the hardware and get rid of hardware development cycle. But to integrate, we must also have virtualization so that we still have separate identity in terms of safety and security part of it. Communication is very important aspect. Then we are talking about the system and software architecture. So because we are talking about SDV as a topic, it is more of a software architecture. And some of the use cases which are not just within the in-vehicle systems, we are also talking about use cases which are processed in vehicle, outside the vehicle, and also at the cloud level. So taking those buzzwords of technologies which has already solved these problems in IT world and trying to map them in automotive world, what is the final solution? That's where we are talking about software-defined vehicle as a topic. So how do we realize SDV as a topic? What do we need? I think the first thing, we have various computing options. So we are talking about part of computing in-vehicle, part of computing on an edge device which is outside the vehicle, and then finally we have cloud computing, which part of the computing will happen in the cloud. So we need to find one solution which can cater all those 3 areas together. Then what do we need? We also need a mechanism, a platform by which we can develop application the way we are developing it for in-vehicle. We need the same mechanism, same way of development also for outside vehicle developments or equipments which are being developed for outside vehicle. And we need the same methodology also on the cloud. So how do we converge all those 3 together? Yes, again, the answer is a lot of learnings from IT world, where the problems have already been solved. But within this, it is not possible. So of course, one of the things is cloud native platform. What do you mean by cloud native platforms? Is in IT world, there are many evaluations within the software development, the way software architecture has been developed. And if you look at cloud spectrum of technologies, there are multiple technologies within the cloud spectrum where people have solved the problem in different ways. Now, cloud native means bringing all those learnings under one umbrella and extending that same in-vehicle computing. But this is not going to solve our problem. I think most important thing is the communication. And if you look at the communication part in today's automotive, it's predominantly a canvas. There are few other buses also available, but now we need to look at communication, which not just a CAN bus, it has to also deliver use cases which are with very high computing, very high bandwidth requirements, and we need to extend the same communication methodology not just within the vehicle, outside the vehicle to the cloud. So we need a virtual bus which can cater a common requirements altogether. And lastly, which is the predominant requirement from automotive, is we still need a safe car. We still need the secure car. So we need to have safety and security built inside the platform itself. Lastly, I think we still need to build ecosystem around what we are developing as an architecture within the SDV. So we still need a software development kit. Another aspect, we just talked about OTA. So one of the demands from consumer today is if they need functions, newer functions in the existing car, and we are developing functions in an iterative way, can we push those functions to the end users as they are being developed? So we must have an infrastructure which will help us delivering the updates, delivering the upgrades to the car over the air, like we have in today's mobile world. HPC infra is more in terms of, because okay, if we are talking about ECU consolidation, we are talking about virtualization, which means we are going to share resources. So for example, we have a GPU within some of the systems in the car, and now there are multiple subdomains within the car, like ADAS requires GPU, your infotainment system requires GPU. Do we have two different GPUs? No. Can we utilize one single GPU and still have a sharing of those resources? So how do we manage those sharing with all the multi-domain use cases running on one single hardware? That's where we also need a HPC management, high performance computing management, where we will control, we will prioritize all the running use cases depending on the criticality of the use cases. So this becomes the backbone in terms of SDV in today's world. Now we have to also look at another trend within the automotive industry in terms of how we are looking at the EE architecture or EE network within the vehicle. So there have been a lot of new talks again within the EE part of it, and how, I think the topic is how software-defined vehicle as an architecture can solve all the EE demands that are being happening within the automotive world. If you look at EE part or EE architecture part within the vehicle, there are two predominant requirements. One is, of course, whatever we looked at in terms of new functions. So there are systems and software demands in terms of specific fulfilling all the case part of it or cases part of it. But there are also demands coming in terms of, if I have to, let's say we are talking about 14 display systems in the car, in today's car or upcoming cars. So how do I route a LVDS or HDMI cable within the vehicle? Because the displays are located in different areas. If I have, let's say, 8 speaker system, how do I write the analog cable across the vehicle? That will also increase the cost. That will also increase the complexity. And again, there are feasibility part. So all those complex. So together the SDV is the answer. And we will also look at how these areas are evolving and how SDV can answer this. Okay, from a EE point of view, there are 4 buzzwords again. So today we are at distributed EE network. We kind of also have a domain controllers in today's cars. There are few OEMs and tier 1s are talking on the zonal architecture, and that will become a predominant architecture. Few OEMs are directly talking about the fully vehicle level centralized architecture. Just to take a case of Tesla, so Tesla started with a fully centralized vehicle architecture with their first model, and slowly they realized that, okay, there are challenges in terms of having fully centralized architecture because the overall ecosystem itself is not ready at this point of time. And that's where I think the middle answer or a hybrid answer could also be, can we have a zonal architecture where we can reduce all the wiring dependencies and still have a mixed computations in place. So one is the zonal architecture and then slowly move towards central architecture, or we can still live with the hybrid mechanisms. There are again pros and cons with every architecture. The point is, how do we define whether this is good or that is good? For some OEMs, this is good. For other OEMs, that is good. Again, it depends on vehicle models, the cost, the overall ecosystem, infrastructure, and all those things. But the important point is, if we go for all of these EE architecture, how do we take the SDV topic and try to solve all the possibilities together? So this slide indicates there are multiple computational areas in the today's vehicle, starting from sensors and actuators. We're also talking about local controllers. There will be real-time requirements, so you will still need some local controllers. We will also have zonal controllers where it is residing at different places, like it could be on left, right, front, back, whatever. We will still have central computes where maximum computational things can be clubbed together. And then we are also talking about cloud. So I think the idea here is, how do we plan? If there are multiple use cases which I have to implement, multiple functions I have to implement, how do I plan them? So this kind of table indicates, if you are on sensors and actuators, you will still go with classical automotive approach of development, mainly because we still need to deliver real-time applications. Moving further upper side, we will go more IT side computational engagements. We can merge multi-use cases together on either a zonal controller or a central controller. And the cloud, it is already there. So cloud side, it is already there. So we are kind of moving from a traditional automotive towards the cloud, but in between we also have managers. I think there are also a distribution in terms of what are the communication part, what technologies to be utilized. We can go more in details offline, but this is just a reference in terms of how do we plan different use cases using the SDV as an architecture and also for different EE architectural requirements. Now let's look at how do we, it's a very top level view of how do we solve using SDV methodologies, how do we solve requirements of all the architectures. So today we have distributed our domain where we have a dedicated ECU with certain functions. There are, so of course I have not shown any actuators in this diagram, but we can have sensors and actuators. And there are also interdependencies which has been solved with CAN bus today. So this is the current outlook, let's say, for a specific use case. If we go more detail, we can still start developing concept of SDV with today's domain-based architecture, but it's more bringing the software architecture aspects first as a step number one. Divide your overall applications into services, so we can bring more methodologies in terms of architectural aspects, so that though we are still talking about domain controllers, but we kind of preparing ourselves for, let's say, a zonal controller or central controller. Then once we have this architectural step, we can go one step ahead. And when we talk about zonal controller, we can also have different topologies here. So we can have, let's say, a zonal controller where there are combination of, I'm moving some of the sensors and computational part to one zone and other part of sensors and computational part to other zone. So we can still have the use cases running and still have the zonal controller in this way, or we can also have a kind of not mega central compute, but a step number 1 central compute where most of the high computing aspects we move to the central compute, and we keep zonal either as a sensors and actuators, or we can still add some degree of computations here. So this way, not only we can be ready for future, but it will also be a step-by-step approach of moving from today to tomorrow. And of course, we can directly also jump to central compute. Again, everything can be packed up inside one central compute, and of course, eventually, once we have central computes, we can have multiple central computes as backup in terms of safety and functional safety aspects. So this will be the roadmap for different OEMs planning, of course, OEMs and tier ones. And it has to be driven from the OEM side. So this will be the roadmap in terms of how do we adapt software-defined vehicle as a topic. I think the next part is at FEV. So what we started is, first we started with our own internal project because the topic itself is new. And there are many, many challenges in terms of on this topic making this reality. Slowly we realized this will be the end structure for us. We still need all three computational areas, mainly the in-vehicle, edge computing, and the cloud computing. We need one platform where we can build services. Those services eventually, maybe in first step, will not be migrational services, but eventually we should be able to have that migrations between these services from in-vehicle to out-vehicle or to cloud. And we are having mechatronics layer for some of the very hard real-time requirements. We can go in details of each of this. So mechatronics layer, very hard real-time requirements, we will still go with classic AutoSAR or RTOS-based development. There are also some of the areas where OEMs are also going with FPGA or their own chip approach. This will still be a traditional automotive development, so the skills required will still be the same as of today. Slightly moving upper, this is the layer where it is more coming from either open source or third party, mainly the hypervisor or some of the operating system aspects. There are different worlds already in place. We are talking about Android, AGL, there are QNX, Green Hills, so all of them, or Linux. Red Hat is also coming up with real-time Linux version. So all of them will place here. I think important aspect in the previous slide was, we will cover it up in the next slide. Virtual bus. So can we have one virtual bus definition, not only for inter-service communication, inter-virtual machine communication. So if service A is on virtual machine A and service B is on another virtual machine, they will also use the same mechanism to communicate. Same mechanism across different computational hardwares, or even extending the same mechanism to edge and cloud. I think there are consortiums being built. There are also frameworks available which are being built. There are also third-party or commercial options available. But yeah, this is also one of the area where all the OEMs and tier ones are growing. I think lastly, the application part where we will go a little bit deeper on the next slides is the SOA or microservices part, which is coming from the IT world, and very relatively new area for traditional automotive people. I think one of the major aspects of SOA, bringing SOA or architectural aspects, is moving from C development to C++ based development, where It's not just a language change of development, but it's also the very basic change is how you architect your applications. It's more OOPS concept has to come. So little bit deeper in terms of how do we go in a SOA world. So SOA is service-oriented architecture, very widely used in IT world in the cloud technologies. The main idea of bringing SOA is to reduce the complexity. How do we manage software complexity, which is very, very complex in today's world, mainly because of the SOA gives a clear definition of each service, what the inputs are, what outputs are. It also helps interconnecting these services together. And then I think it gives a mechanism by which you can manage all the dependencies between different functions together. One of the advantages of SOA is also that you can start building each services in parallel. You can test them in parallel, strengthen them to 90% readiness, and then integrate them together to deliver the final solution. So overall time to market is also low. This is one slide from Orally. I think there is a common questions being asked whether we should go for SOA in automotive world or whether microservices are better. The answer, what we think is both are required. Both has plus and minuses. One is being message oriented, other being API oriented. I think the advantages of microservices is more reusability, whereas SOA is more one in terms of easy to implement, and other in terms of, I think the biggest challenge with respect to adapting SOA or microservices in the automotive world is more you architect, more there will be problems of latency handling. So more hops you will add in the software, and more hops means you will have challenges of latency, which is the primary requirement in automotive world. How do we implement any functions, any use cases using new buzzword in terms of SOA, getting them to reality? So within FEV, we have come up with a model dividing everything into 3 layers: functional decomposition, which is we will also see, a communication model, and then finally deployment model. This way we can generalize the overall development methodology. The functional decomposition, it's a traditional software architecture. Any software architect will talk hours and hours about functional decomposition. Of course, I think most important factor is how do I define, break down pieces of my software into some reusable software, and also have connectivity between them. But again, we have to come back, do I over-architect? That will lead to latency issues, or am I doing under-architecture, where I will not potentially fully utilize the SDV topic or the architecture itself. But I think this area, there are a lot of tools, methodologies already established in the IT world. All we need to do is to grab those and apply them in automotive. Second area is more data communication, where majority of the shift will happen, because today everything is signal based. We have to move to a combination of signal and service based. Of course, the end goal is to move everything to service based, but that's where if we pick today's software and then try to move it to SDV world, we will need some mapping between how it has been handled today in terms of different CAN messages, how we will handle them in SDV world in terms of whether it's a request response, whether it's an event, or just shoot it's like a SMS shoot message and forget about it, or it's an important field which I want to get updates every time. So I think this will be very important aspect in terms of making the SDV very successful. The last but not least is the deployment model, and that's where all the complexity will be there, because if you're talking about SOA or reusable services, we can develop services in one go. Those will be ready. And the number of services developed, the numbers will increase continuously. The challenge will be if I have 5 functions to be delivered, as my vehicle needs 5 functions, or another vehicle needs 15 functions or 8 functions. So how do I deploy these existing services in a defined environment? Because that's where the cost, performance, everything will come into picture. So again, there are 2 areas. Of course, the system partitioning will be the most critical ones. Do I need 3 virtual machines? Do I need 1 virtual machine? 5? Do I separate 5 services in one, 2 services here? How do I reuse? There could be 1 Ethernet port, 1 CAN port. Both, there are multiple services trying to send data over the Ethernet. How do I prioritize the data? So all that will kick in as part of system partitioning and resource utilization, prioritization part. And the second part comes in terms of how do I deploy different services together? Should I deploy 5 services, 8 services? How, if I have, let's say for ADAS, I have, for one problem, I have 3 services depending on current available. So for example, I can just take an example of navigation service. I can be connected on cloud. So whenever I'm connected, I will have more efficiency in terms of navigation. If I'm not connected to the cloud, I will still have a navigation system, but may not have a 3D maps in it. So I will have 2 services running together, but at a time I will be using one of them. So how do I plan this? How do I select this? And how do I do a transition? All that will also come in terms of the mechanism of service deployment. So the challenge or where people like us in terms of service engineering service providers will help is you have your product definition, you have your services ready, but how do I integrate and deliver them in one system? And that will be specific to each program. As I change from one program to another program, I change functions. I need to reconfigure all the deployment aspects. Lastly, I think because we are talking about reusable services, we also need to change mindsets in terms of development. So we are also talking about MBSE as a topic in general being utilized in engineering services or engineering development. So how do we connect SDV development with a mechanism by which we can still have a very high level definition of how we developed applications, but slowly go towards auto code generation areas. So again, this is part of it could come from future. So defining, so we all know SysML, customizing the SysML in terms of specific to automotive. And if you look at some of the buzzwords, so Daimler trying to create MBOS, VW trying to create their own OS. How do I create my own platform? How do I create my own kind of custom SysML? Define everything in those areas and then try to develop my ECUs, applications, services in an automated way. So this is eventually will help us in faster development of services and faster deployment of the services. 2 important aspects within the SDV is security and safety. How do we manage security in this distributed environment? I think, again, there is a lot of learnings from IT world. So people from networking domain are very aware of concept of VLAN, virtual LAN. And the same methodology we will have to apply in terms of our virtual message bus, where we can create virtual domains. The data from one domain to another domain will be controlled. So part of the data can flow, part of the data cannot flow. So platforms will need these control mechanisms where they can control what data is being transferred from one domain to another domain. By having that, they will have security in place. And of course, there are traditional ways of implementing security at hardware level, at software level, at OS level, and then also at application level with all the cybersecurity concepts. Lastly, functional safety aspects. I think important thing is, apart from your regular functional safety aspects, what are we now talking about additional things which we have to take care of by bringing SDV architecture, so more focusing in terms of the hypervisor world, the virtualization world, and what are the additional aspects that we will have to bring in together. How are we helping our customers? I think we have already doing some projects with some of our customers where we are doing POCs. We are also trying to build their own platform. One of the customers where we are bringing their IPs together and trying to transform them into SDV architecture. So they already have some artifacts in a traditional way. So we are trying to migrate them in and trying to deliver them this. There are also areas in terms of developing the services. One of the aspects of SDV, which I missed earlier, is also how do I bring in agile development? Again, a very popular methodology. How do I bring continuous integration and deployment, CI/CD? And one other aspect in terms of how do I move all the tool chains, which are customized now for SDV, not only developing those tool chains, but migrating those tool chains to the cloud so that we can have a real distributed development environment. And of course, finally, as we talked about, how do we develop MBSA approach for SDV? So this is where we are developing or helping our customers. Apart from application development, selection of the hardware, selection of third-party components, we are also helping building safety and security mechanisms for the SDV. Of course, this is a very new topic. Not much development has happened across the globe, but yes, that's where there are a lot of questions still to be answered, and we are there to help you. Yeah. So any questions?
Yeah, I'm Chandan Sahani. I have two questions.
Yes.
The first one is, how do you see Ethernet becoming relevant for, say, especially for the EV HV architecture? And second would be, what would be certain decision points whereby we can choose between SOA to microservices? It could be functional safety or other parameters, because today we are on microservices. So how do we migrate to SOA if that has any merit?
So I think the first part was it with respect to LV part. Yeah, I think Ethernet is kind of must now. If we want to realize SDV, Ethernet has to be on forefront. And whatever the gaps which Ethernet had in terms of deterministic latency part, which was the most critical missing link within the Ethernet protocol, that has been addressed now, not only at software level, but also at the hardware level, the chip level. So with the time-sensitive networking, I think Ethernet can replace CAN bus slowly. Of course, there will be stages. Firstly, non-real time, then slowly mixed or semi-real time. And then eventually we should be able to replace hard real time from CAN to Ethernet. So yes, Ethernet is must. I think the second question in terms of SOA and microservices, again, it's a typical, very critical architectural decision. I think both will exist. Both has advantages. And we have to look at services, look at what are the input outputs, and then make the decision. One eventual problem with microservices could be the latency, and that's where we still need to make a choice, because we will not be able to jump directly to microservices from today's embedded world. And that's where SOA in between may help as a transitional step.
Thank you so much, Mr. Anand Bhange, sir, for sharing your valuable thoughts. Thank you so much.
Any questions? We can talk.
Software-driven cars are not just a mere imagination now, but slowly and steadily turning into a reality. Let that realization sink in as we take another short coffee break. The program will recommence after 10 minutes. So I request all the attendees to head over to the dining area. Thank you. But remember, this is just for 10 minutes.
slide डाल कोई भी. अभी वो देख पा रहे? Thomas, can you see the slide?
I can see the slide. Thank you.
Perfect. Now, this was a short testing we were doing. Just 1 second. Let us show your picture. Can you switch on the camera, Thomas? Meanwhile, we just wanted to show you quickly whether we can see it here.
Okay.
Perfect. We see you as well. Great.
Okay.
Great. Just 1 second, Thomas. Anything else you want to check? You go on the stage and have a word. Let us check once again. Speak now.
Hello.
Thomas,
can you hear me?
Yeah, I can hear you loud and clear.
Okay.
कोई बात क्या फर्क पड़ेगा उससे?
So there is no audio for this slide, right? The slide you are seeing on the screen?
I see one page and I see you also in the
Shrikant,
left corner.
see in the camera. See in the camera.
I cannot hear Thomas clearly.
You cannot hear him?
Cannot hear him clearly. If
Okay,
feedback-
I can hear
No,
very well.
it's not on your side, Thomas. I think
Thomas,
it's on
it is
this side.
maybe a
Feedback
sound
नहीं
system
आ रहा है
here.
यहाँ से कुछ.
Let us do one thing. When Thomas will speak, you better come
Yeah.
here. That makes more sense, no? Okay. Say something now.
Thomas?
Yes?
Yeah, can you? Yeah, I can hear you now.
Perfect.
I can hear you very well now.
And you can see
And
us
I can
as well,
hear
the
you.
happy faces. Yeah?
Okay?
Okay.
Right.
Great.
I request everyone to please gather in the hall so that we can start our session. एक बार बाहर जाओ, ऐसे ही रख दो. माइक ले.
Hey, check. Hey.
All the attendees who are in the dining area, please come to the hall so that we can start our session.
Hello. Hello.
Now, this is my third call to all the attendees. Please come inside the hall so that we can start our session. I hope I am audible to everyone. That is not. I have sent someone.
Gentlemen, please head towards the...
Yeah.
Hello?
Let's have another quiz round. So the question is, what is the full form of PLI scheme? PLI scheme. Not like that, sir. Let us give us some time. Pardon?
Production link incentive.
Yeah, already. Yeah. Thank you. Now another question is, newly found FEV group company name, which provide smart mobility solution.
People joined FEV.io.
Sakshi, the one with the orange shirt. Yeah, there. Yeah. Thank you so much. Now I think I have to start our session. Let us now make fresh forays into the formidable topic of battery design and its safety challenges. In recent times, we have seen incidents where automobile manufacturers, they have come under fire for battery safety. To navigate through this challenge, we have invited seasoned technologists who will next share their outlook. Dr. Thomas Hulshost, Global Vice President of Intelligent Mobility FEV Group. He will join us virtually. Since joining FEV in 2002, Dr. Thomas has played a key role in the advancement of the electrification and electronics business unit. Dr. Thomas has launched the new Smart Vehicles Engineering as an interdisciplinary and comprehensive approach for intelligent, connected, and automated vehicles. Dr. Shrikant Nagpure, Head of Battery, FEV India. He is a seasoned technocrat having 14 years of experience in battery research and design, characterization, testing, as well as manufacturing. So I request them to please join us.
Hello, everybody. Hello, Thomas. Can you hear us?
I can hear you crystal clear. I hope you can hear me as well.
Yes, we can hear you crystal clear here as well. Let's start with our talk. Yeah.
Yeah, okay, thank you. So thank you, Rajni, for the kind introduction. So it's a pleasure for me and a honor to join, unfortunately only virtually. I will be in India nevertheless next week, so maybe we find an option to meet. Yes, I will do a brief lecture about the battery design and of course with a specific focus on the safety challenge. So I directly want to introduce in general what is going on in the EV world on the next page. So I think the general development we see globally was already introduced this morning by Alexander. So the global passenger cars market is definitely expected to shift more and more to the zero-emission vehicles. Europe, for sure, is in the lead here. So we already see a significant share in 2030 of 45% of pure electric, speeding up even more in 2035 with an 80% share we expect more than 80%. Of course, it's mainly pushed also by European Union regulations, which are already decided. So a similar development we see also in US and also China, a little bit slower, but nevertheless, we see this strongly increasing share of EVs. So however, India is becoming a very ambitious player here and pushing this electric cars development a lot. So based on the Indian government announcement, so we expect a share of at least 30% already in 2030, while 2035, India would already be ahead of China and US with a share of 70%. Of course, this is, I need to say, the acceleration, the accelerated transformation. So, but honestly, over the last 5 years, we experienced that even our most aggressive scenario was never aggressive enough. So that's why we more and more believe in the more accelerated transformation. So again, a little bit more into the details for the Indian situation. So we see here, even with a moderate scenario, can we go to the next page, please? Even with a moderate scenario, we see an EV share already of 25% in 2030. So of course, the Indian government is pushing this electrification with several initiatives. So the FAME subsidy program was now extended to 2024. There are various initiatives for charging infrastructure. There are plans to build up and subsidize Indian battery cells plant, which is a core activity. And also the reduction of import duties for BEVs are under discussion. So please note also for the two-wheeler, the three-wheeler, it will be more aggressive. So here there's a clear statement also from the government, target is 80% already in 2030. So can we go one step back, please? Thank you. One back. So Page number 4. Can you please go to the next slide? Okay, thank you. So, you know, ABB is very active in this whole area of electric powertrains with a wide range of engineering services, right from a system point of view, so doing the layout of a specific technology, sizing component, large vehicles, being into the system control, train control, but also digging into the component development. Of course, there are major activities, the drive itself, the emission inverter, but also the EDU with a very high integration. And of course, one of the core activities we have the battery. The key trends we see here, the mobility system, is we have modular systems, scalable platforms, that we have a bigger share light and heavy duty, that we see the 2 and 3-wheeler industry, of course, with a very high pace going into that, and also off-road applications are in the focus. For the controls, we see more and more predictive energy management, really getting the situation to bring the best potential of powertrain to electric range. We see also a trend for powertrain neck controller, people motion control, so that means merging functions more and more together to combine, for example, acceleration, powertrain functions with deceleration braking functions. And also, we're going more and more into a torque vector setup in combining chassis control with powertrain and braking. So for the e-drive component, of course, there's a strong development for the silicon carbon, the high power area, and the gallium nitride for more the low power application. We see also a big trend for so-called X-in-1, so bringing together components, for example, the onboard charger together with DC-DC. Of course, there's a huge demand on ASPICE development for the software part of it. For the EDU, which is the next area, the key trends, of course, always is to get high power density at the same time to increase efficiency. So we see both multi-speed axles, for example, for heavy duty, as well as 48-volt technology, more for the light duty vehicle, still being of interest.
Thomas, sorry to interrupt.
Yes, please.
I think there is some trouble with the audio here. So if you don't mind, can I continue for a few slides and then we can see if the audio is better again from your side? Okay. So talking about the key trends in battery, propagation, high power charging. So charging, fast charging is one of the major demand right now from all the OEMs. In terms of pack design, we have been talking since morning about this configuration, cell to pack, cell to vehicle. Solid state battery, that is one of the safer chemistries considered right now. It is assumed that those will be really safe compared to the liquid electrolyte batteries that we have currently. And especially since we are having this event in India, talking specifically about the hot country, the tropical weather, the challenges related to that. So as our EV market grows, we have to focus on these key trends, the hot country region for the battery development activities. So in terms of the vehicle cells forecast, you can see here with the accelerated transform, 70% of the light duty vehicles globally sold by 2040 in next 20 years will be all electric powertrain. All right. So we are seeing rapid growth here in terms of the electric vehicles. That puts a lot of demand on the total cell demand. You can see here it's almost 6.4 gigawatt cell demand, 94% of automotive cell production worldwide. So our cell production capacity should go up as we are ramping up our EV adaptation for the future. We often talk about which chemistries we should go with for our electric vehicles. Two most common chemistries that are being talked about and discussed in industry are LFP chemistry, NMC chemistry. LFP is used more common right now. It's very common in most of the electric vehicles. But the next step in this evolution will be the NMC chemistry. Here you can see the comparison between LFP and NMC chemistry. The major advantage with NMC is the high specific energy, so energy per unit mass per unit kg. As compared to cost, LFP is slightly better than NMC right now because LFP is in the market for long time now. It has been consumed in much more quantity, so economics of scales have come in picture. Same will happen with NMC. Safety wise, we'll talk about it in next slide. I guess, let me go back. But safety wise, you can see that LFP has slightly better advantage over NMC because the temperature at which LFP will go into thermal runaway is higher than NMC, and the total energy that it will release once it gets into thermal runaway is less than the energy released by NMC. Yeah. So Thomas, can you hear us?
Yes, I still can hear you.
Yeah.
I hope the audio line is now better, so I switched off my camera.
So let's try again. Thomas, you can take over, please.
Yes, I will take over. Yeah, so this is then the next question. So for sure, LFP has a strong advantage, not only in cost, but also in the safety. But what's about the energy density, which is a weak point? So regarding energy density, the battery system design really matters. So it's not only about the cell, it's really about the system. So in comparison, we see here the cell level, specific volumetric energy density. And we see also the system level specific energy density. And we see here there's always a kind of a ratio between the two. And of course, from a cell point of view, there's a very clear advantage of NMC compared to LFP. But nevertheless, we can find solutions on a pack level to really bring down this disadvantage of LFP. So if you continue, we see, for example, how Tesla Model 3 could come with a pretty reasonable energy density on the pack level, even with LFP. Can you continue, please? Same was also the case for an FEV design we did with both NMC and LFP. And even having a much lower energy density on the cell level, we achieved only a 10% disadvantage on the pack level. I need to say this is the volumetric energy density. It's not exactly like that when you have a view on the gravimetric, but in most of the applications for PES cars, the space of the battery is the more limiting factor. So on the next page, we see this in a more clear comparison. So on the cell level, we see a disadvantage of the LFP compared to the NMC of about 30% roughly. From a module level towards the pack level, we can bring down this gap. So with a good system design, with a good pack design, we can reduce the disadvantage of LFP, for example, by doing cell-to-pack approach to around a disadvantage of only 10%. And that's because LFP batteries, they need less safety measures. And so we can really show a higher volumetric integration potential with the LFP. So I would say the main disadvantage of LFP could really be under control by doing this. Okay, of course, it's also about costs. So what we already experienced over the last years was a significant drop of the cost on the pack level. So what we expect for 2030 is that we have a pack cost reaching a level of 55 to 80 euro per kilowatt hour, which is roughly 50 to 72 US dollars on the long term. Of course, there is a estimated range. So there's the optimistic scenario versus a baseline. So nevertheless, we definitely will come to this up to 60% price reduction 2030 compared to 2020. I need to say the LFP, of course, still has a bigger advantage even in price. So today we see 30% roughly of a price benefit for the LFP, but with increasing approach for NMC, for adding, for example, aluminium or bringing out the cobalt even. So this gap will getting more narrow. So we expect in 2030 the gap between LFP and NMC in 2030 in the range of 15%. So this advantage of LFP will melt down to some extent. Okay, of course, the core challenge, and that's on the next page, is about the safety. So unfortunately, in the last years, we experienced several cases of batteries caught fire. So the first one was a Tesla battery fire, which led to a 12% stock decrease. So we even experienced a reignition 72 hours after the initial fire. So even this is documented. And also, it's not that easy, honestly, to extinguish a battery fire, which needs more than 10,000 liters of water. So there's a clear demand for battery thermal propagation behavior to be kept within limits. So what we also see, one example is the thermal propagation legislation for passenger cars to protect the passengers already in place in China since January 2021. And European Union will follow also end of 2023, so next year. So this legislation has a clear limit. So first of all, a thermal runaway needs to be detected early. The passenger needs to be warned as early as possible. And then at least it will keep 5 minutes duration until really a fire will become dangerous to the driver, so that the driver would have at least 5 minutes time to get out of the car and to bring himself in a safe condition. So that means a reliable thermal runaway prediction model is required for sure. We need to have cells with as low reactivity as possible. We need to take care about the thermal propagation on a module level, and of course, even more on a pack level. So on the next page, what we see here, since FEV operates the biggest independent test center for batteries, in particular for battery packs, but also for modules. So we know very well about the status today. So what we see here is over the gravimetric energy density, the time until fire outside the pack occurred in several packs. So you see in summary, so we did 20 packs in a range of less than 100 watt-hour per kilogram, 15 in a range of 100 to 150, and even more than 50 packs we tested in a range of 150 to 250 watt-hour per kilogram. So pretty high energy density. So what is obvious out of this graphic, even without mentioning the details, is that the problem still is not solved. So we still see that the majority of the packs don't pass this test. And even for the higher densities, the share of, let's say, no propagation or stop propagation, which keep the fire inside the battery for more than 60 minutes, is 0 for the higher energy densities. So of course, again, on the next page, the question was, the journey starts with the cell. And we already mentioned that LFP has a clear advantage here compared to the other chemistries. So this is giving a closer look on more details. So what we see here is a comparison regarding the thermal runaway threshold temperature. So the gas volume released, the self-heating rate, the energy release, which is one of the most significant attributes, of course, the max temperature and the exothermic state temperature. So what we see here is the LFP has an intrinsically safer cathode than NMC. NCA and LCO we see is on the disadvantage side in regard of safety in particular. LFP has a very advantaged temperature safety behavior as well. So highest start and lowest threshold. So that means that it's by design of the cell already giving advantage. So the LFP enters thermal runaway not below 270 degree, while NMC or even LCO can start thermal propagation already in a range of 150. So overall, LFP definitely is the winner here before NMC. But I need to say that also NMC, compared to the other chemistries, is not that bad. Of course, LFP is a clear winner, but NMC is also a chemistry which can be handled definitely if you do a well-done pack design and module design. So that's exactly what we as FEV are doing. On the next page, we see that this development of a safe battery, of course, needs strong support by a lot of simulation and modeling, starting from already cell characterization, going into the thermal layout and the 1D simulation of the cooling concept, also combining this with the vehicle cooling circuit layout, then going in all the details of a 3D thermal simulation to understand what is happening inside the pack. And of course, even with a very strong focus on the thermal propagation. So in particular, also the fire test and all of that. So at the end of the day, all of these simulations needs to be always validated by tests to be as close to reality as possible. So what we start with typically is what is essential for both safety and durability is the layout of the cooling system. So we need to take into account, of course, module dimensions, the arrangement of the modules, the vehicle spec. And with this simulation approach, we can take care about the heat transfers, the pressure loss, the homogeneity of the flow, and also even manufacturing complexity. And what we can get as a result out of the simulation is that we can come up with an optimized channel layout and the dimensioning, the coolant routing to be optimized, and of course, even the coolant in and out properties. So that really brings already big advantage. If we then go more inside the battery pack, into the details of the battery pack, so what we can do here in simulation is to have a high spatial resolution by applying CHT simulation. So this model contains really the detailed geometries of all the design details. And so we can take care about different cells, the connectors, the bus bars, the cooling plate, the coolant flow, and all of that. So we can even consider the time dependency of heat input and how the heat is distributed inside the pack. We can very early in the process identify hotspots, which also are of high interest. And we can then come up with a very good and balanced layout of this cooling concept and the design attributes in regard of the cooling performance inside the battery pack. And that's not only true for, let's say, the design of the battery pack for the normal usage. We can even apply simulation for tests, which typically are very late in the development process. One example is the fire test. So for the fire test, you literally put a battery pack on the grill, you put the battery pack on fire, and you have a clear boundary conditions how the pack needs to perform. So the local cell temperature during the first 4 minutes of a fire test procedure, you see here in detail. And this can be done in the simulation, and that's exactly what you can see here. So what is obvious out of the simulation, that in general the pack is performing pretty well. It looks not that bad. So you see in most of the area of the battery pack, it's green to yellow in worst case. But what we see is one single cell at the upper left corner, which is in the critical area. And this is because this cell is not well protected by the cooling layout. And that's exactly what we can already identify early in the development process and find the solutions based on that. So now getting more into really how to prevent thermal propagation. So we have at FEV a very unique approach. So the question, of course, is how can we fulfill thermal propagation legislation and even more come to a design which is no propagation, or at least stop propagation at minimal cost, and also with a very high energy capacity still in place. So what we typically do, based on the general boundary conditions we have, we come up with a base development. So that's the first design of the battery pack, which of course already is taking into account the experience we have, the mentioned simulation steps, but then we go even more into the details to investigate about the thermal propagation behavior of a specific design. So what we do is, in parallel, we have a very close look on thermal model. But the thermal model alone is not talking enough. So we need also to have a very early proof of the venting gas system. So how we can, in case of even one cell is getting into a critical simulation, how we can solve this issue on the cell level, on a venting system level. So of course we do this beside model validation, again, to be as realistic as possible. The durability test center we have, the test opportunities we have is helping here a lot. And bringing this together, we can then combine this output of the models to come up to a design optimization. And then the next step, of course, will be the pack testing. But again, we would already have an improved situation due to the results of the simulation steps we did. On the next page, in general, we see what we can take care about. So there are several measures which we need to consider in the pack design in regard of thermal propagation. So we can take care about the venting channel definition, the venting valve selection, the filter system selection so that it won't get clogged, the E-box safety concept, which is typically a thermally protected EE box, then the thermal insulation on a cell level and on a module level, and then also, of course, the electric insulation of the high voltage components, including, for example, bus bars. So what we do then, design step, in the design steps is that we do dimensioning of the venting channels, and also the passing to prevent local pressure buildup. This is always a problem. The filtering system needs to be applied in a way that we can prevent external ignition of released gas outside of the battery, while at the same time not clogging. And again, that's really a big challenge. So if the particles getting out of the battery have a high energy content that could cause ignition outside of the battery, at the same time, the filter needs to be sized very well to prevent also clogging. So the venting valve selection to define opening pressure and also the maximum release gas flow is one of the design steps. The high voltage cabling, so for example, also the insulation of the bus bars. So it might be the case that for example, particle flow will also have a kind of abrasive impact on the bus bars insulation. And that, of course, will also be a problem. Cell-to-cell thermal propagation protection by heat-resistant distance pads like mica sheets, and of course also module-to-module protection by implementation of these heat shields and walls between the modules. So that's what we can do and what we typically do then step by step in a design. So taking care about all of these attributes. So one example on the next page is how to improve the insulation material to give more time for heat dissipation to uncritical components so that we can prevent that really a thermal issue which is happening on one single cell will step over to the next cells and will cause thermal propagation over a module and worst case even for the whole pack. So the simulation case we did here is to take care about 3 prismatic cells with 2 millimeter of insulation between the cells. So the first cell was overheated on one side due to short circuit, and then we have this heat dissipation on all other sides. So the result is that the next generation of thermal insulation really brings a big benefit here. So the heat dissipation to the neighboring cells could be reduced, and the heat instead dissipates to other directions, to other components which are less critical. So the insulation material really makes a big difference here. On the next page, we see what I already introduced. So first, on the left side is doing a detailed simulation about the thermal behavior. So in detail, you see here that one cell was overheated by a heat plate applied to a single cell. So we do the same in the test. So we one by one do the simulation according to the test. So we see here, first of all, if we have a closer look to the cell taps, that of course the cell taps and the bus bars are critical to bring a thermal propagation from one cell to the other. And also what we see on the right side, without a heat barrier, that's not only limited then to a single module, that even is then getting from one module to the other. So that's about this thermal effect. On the other side, and please start the simulation video, it's about the venting valve and the venting system opening. So as soon as we have gases in the battery pack, of course, the pressure increase. We see how the venting channels, in this case, it's upside above the modules, what we see here, are distributing through the battery pack until the venting valve is opening. And then, of course, first of all, the air will disappear to the venting valve, but then, of course, also the gases will get out of the battery, what's just happening in this picture right now. So this already gives a very good evidence about the overall pack design, in particular regarding the venting system and the valve layout. And we can even get closer to what is happening, what we can see on the next page, which is taking a closer look on the particle flow. This shows the particle deposition and agglomeration, which is used to improve the flow field and to avoid also arcing risk. So on the left side, we see the simulation of the particle flow. So you see by the color code, the size of the particles. And by the design of the pack, we see that the bigger particles already are more or less in this, they remain in the system. So whatever might clog the vent is already by design, let's say by the venting system layout, to care that it will not be like that. And also the high flame front temperatures we see in the worst case. Worst case means that the gases will caught fire. See that the high front temperatures and the pressures from the ignited gas really can harm the pack components. I already mentioned the bus bars, but also the other components inside the battery pack. Okay, then on the next page, okay, that's now the simulation. So we can really do the simulation dynamically. And again, you see by the color code that the particle size really makes a big difference. On the next page, what is also pretty critical, of course, is arcing. So we need to take care about arcing as well. So arcing might be caused by an electrical breakdown of the intermediate gas. We have the high electric field strengths to be considered, increased electric field strengths to the melting of electrical insulations, like again, insulation of bus bars, and shortened gaps to accumulation of particles and other cell matters. And we need to decrease breakdown voltage, or we need to take care about decreased breakdown voltage due to ions in the flame front. So the risk, of course, is to get an additional energy release inside the pack. And that might, of course, also be a source of ignition of the vent gas and the air mixture. And so that definitely will really become the worst case. So we have some mitigation strategies here as well. So well-defined venting channels, as mentioned already before, circuit breakers in case of thermal events and bus bars, being also melting fuses to reduce the voltage differences, thermally resistant insulation materials, and finally also additional thermally resistant shields. So arcing, honestly, is so far in preparation. So we are working on arcing models for our simulation as well. Coming now to the final part of my presentation, which is having a closer look on what we do in the battery testing, in particular in regard of thermal propagation and safety. So as mentioned, FEV is operating the world's largest development and test center for batteries. And let me start with a short introduction video about this EDLP. Please start the video.
In Sandersdorf-Brena, FEV operates the world's largest development and test center for high-voltage batteries for passenger and commercial vehicles, the EDLP. With a total area of almost 60,000 square meters, 69 test benches are in operation. The batteries must undergo a demanding testing program at the EDLP. The spectrum ranges from endurance and performance tests to mechanical, environmental and abuse tests. Basically, everything that customers want to have tested according to the international standards. For this purpose, the EDLP operates continuously, 24 hours a day, 7 days a week. Just one of many examples. The environmental tests also include a test for water ingress. During the IPX test, the battery is exposed to the load that can later occur when driving over wet roads and through puddles. Even the behavior in extreme weather conditions, such as floatings or during a visit to the car wash, is checked in the dip tank. Another highlight at the EDLP is the shaker, the largest of its kind in the world. This is also where commercial vehicles' batteries can be tested for mechanical loads such as vibrations and shocks. The advantage of EDLPs is that we perform all tests required in a validation plan at our location in Sandersdorf-Brena. This results in very fast project turnaround times, which are accelerated even further by our 24/7 operating mode. By the way, our testing services are not only available to the European market, we also offer tests that comply with the standards in the US as well as the Asian market.
Des asiatischen Marktes anbieten.
Okay, thank you. On the next page, I want to emphasize a bit more on what we do in regarding testing approach. So what we do here is we start on a cell level, of course, to already get as much as possible information about the different cell chemistry, the different, let's say, samples of the different suppliers. The next step is to bring together several cells together, stacking the cells and doing a cell stack testing. For example, already doing penetration testing. On a module level, of course, it's definitely a core to take care about regarding propagation. We do this in a propagation box. And finally, the final tests are done on a pack level, where we do both nail penetration on a pack level, but also, for example, heat plates, applying heat to the pack. On the next page, we see that we have different causes in general of thermal runaway. So it might be an overcharging situation, it might be external heat, it might be an external short circuit or an internal short circuit or a deep discharge. So all of these might cause a thermal runaway of a single cell. And what we do in the testing is really covering all these different root causes and to investigate about the thermal runaway behavior of the pack and the module. In the next, I will just share some impressions with you about how such tests might come out. So, of course, I selected tests which went not that well, on the pack level at least, so to just give you an idea what might happen. So please start the video. And I hope that also the sound is working. Okay, it seems to be that the sound is not activated. However, so it's a pretty loud. So we see here the electrolyte evaporation here and getting out of the battery pack. So again, just a single cell was overheated by a heat plate here. A single cell was overheated, and that's the reaction on a pack level. So of course, we're doing this test and we're doing a lot of analysis about root causes, about design aspects, how to improve the design, of course, to really get into a safe design at the end of the day. So we're doing such kind of tests for a wide range of OEMs and also tier ones. So that really helps us a lot to get an overview about where we are today, and also a lot of, let's say, good ideas how to improve the situation in the design by understanding better and better about the different root causes. So this is one example on the pack level. On the next page, there's another impression coming from another heat foil test. So I need to say this test was pretty successful. So we did the same. Of course, the pack is a smaller pack, and we also have a different chemistry, a different kind of cells. Please start the video. What you see in this video is that you see still a lot of electrolyte evaporating, but nevertheless, no fire getting out of the battery pack. So this design was done in a way that, of course, still it's not a nice situation, but at least you could keep the fire inside the pack, or even no propagation inside the pack in regard of thermal issue. And then finally, another, and that's the final impression I want to share with you, is a drop test. So it's dropping a module from a height of above 6 meters, and you see what happened sometimes by just dropping a module. And again, this is one of the modules failing the test. Honestly, statistically wise, most of the modules survive the test pretty well, but still some examples we experience like that. So then let me come to the end of my presentation. So summarizing the key findings. So we have this requirement regarding higher energy density, longer range of the EVs, but together with the stricter thermal propagation regulations. And of course, not only the regulations, it's our own interest to also keep the safety in a very well balanced to the risk, and to stop or even no propagation design is the clear target of all the manufacturers. We're supporting that. So the thermal propagation mitigation is mainly focused on a design measure, or on several design measures as introduced. The venting channels, I mentioned the valves design, the particle filters, and also advanced interface materials, which are really helpful to achieve these goals. So we have the improved simulation methods, which is again a pretty unique approach of FEV to this degree of detail, which really helps us to make the design decisions early as possible, and also to decrease development time and cost. And finally, this cascaded testing approach from a single cell level to full high battery pack level, of course, is a very time and cost efficient way for doing the validation, and to find a way to parameterize and adapt and validate the simulation models in parallel. So overall, and that's my final statement, if you are in batteries and if you are interested in this, so FEV can really support you, really from doing the selection of the cells up to getting into all of the testing for all the global markets. So, and I would be more than happy to continue this discussion with you face to face, maybe next week when I'm in India. Thank you for your attention. I more or less kept the time, I hope. And yeah, many thanks for your attention.
I thank Dr. Thomas Hulshost and Dr. Shrikant Nagpure for sharing these insights with us. So, one quiz question. What is the full form of FEV? Full form of FEV. Thank you, sir. And now, I would like to ask if you have any question regarding this topic. So, Dr. Shrikant Nagpure is with us.
Thomas is also there with us.
Dr. Thomas is also there.
Yeah, hello. Am I audible?
Yeah.
Yeah, my name is Prasanna from Tata Motors. I have two, three points or questions over here. One is when we are talking about the heat rejection from the battery. So what parameters are more important? Is it only I square R, that is what is the heat reaction, and some minimal component of chemical reactions? And how much is the impact of basically hot ambient conditions like India? So is it creating any addition, or will it create any problem uh, when the battery is getting charged or discharged and there is a hot ambient condition or a hot soaking condition? Will it create any problem for, is it adding any heat reaction inside the battery? Will that have any impact?
Thomas, could you hear the question?
Honestly, I couldn't get it completely, so audio is not very good. There was one aspect I hope I catched up, which was about the hot climate conditions we have in India. Definitely that makes a big difference. Let's say the average the battery experience over lifetime defines more or less the lifetime. So the aging will be accelerated by a higher average temperature. And of course, it has also an impact on the safety and the thermal layout of the whole pack. And as you mentioned, even during charging. Yeah, so that's not only for the battery, let's say, in action, but it's also the case for the car just parking somewhere. We might achieve temperatures in a range of 60 degrees, for Indian conditions. And again, also during charging, we need to take account. But Shrikant, maybe since you're hopefully got the full question, you can complete my answer.
Sure. So I would like to add one more point to what Thomas was saying. Not just the cycle aging, but in tropical conditions, we also have to consider calendar aging. So our vehicle will be sitting in parking garages or outside our house where your thermal cooling system is not running now. So your average cell temperature may go up slightly more than what you would have normally in a lab condition or in normal weather conditions, right? So that could slightly factor into the calendar aging of the battery pack. And regarding your first question where you said I square R losses. So I square R is only the heat loss. The main heat or the main cause is the short circuit or the initiation of short circuit within the cell that leads to the higher reaction rates, and these higher reaction rates are accompanied by higher heat release. So that causes sudden temperature rise, and that leads to the thermal propagation. So that needs to be controlled. Basically, you have to monitor the temperature, you have to predict, if possible, if it is going into thermal runaway, and that was the GB standard that Thomas was showing, that you have to inform your driver 5 minutes in advance. So you have to predict that happening. And if it is happening, then you have to have strategies to control its propagation.
Okay, one quick question. Now, considering all these conditions, soaking, hot ambient, charging, discharging, all these worst cases, so what is the safe limit for LFP and NMC? Battery cell temperature, safe limit, considering like India, 45 or 48 degree ambient, charging, discharging. What is the safe limit? Battery cell temperature.
So Thomas, the question is, what is the battery safe temperature for LFP and NMC?
Yeah, so as mentioned before, there's difference between the chemistry, but nevertheless, I need to say in our design and also in our BMS, we always take care that the temperature will never come up to 60 to 70 degrees. So for NMC, for sure. For LFP, you have a little bit more of tolerance, but nevertheless, I would say if you don't have external fire, it should not come up to the 70 degree. And again, so that's more a kind of an engineering point of view. Of course, you might go upper to higher temperatures for LFP. Again, the activation temperature is much higher. It's above 200. But nevertheless, to keep the design as safe as possible, our algorithms will take care that the temperature will not get above 70.
Actually,
Hello.
I'm Kapil.
This is Ram from Mahindra. Thanks for a good presentation. Can you throw some light on passive cooling arrangement, which are quite important for thermal management? Like what is the way forward, and it really help in terms of passenger electric vehicle?
Passive cooling system. I cannot see where the question came from. Passive cooling system, you're talking about basically air cooled?
No, it's thermoelectric cooling, which more having a lot of advantage in terms of commercial thermal management. I want to understand more on in terms of passenger electric vehicle.
Yeah, maybe if you allow me to just share one experience we gained in 2010. So in 2010, FEV had a fleet of electric cars on public road with an own battery design, which was completely passive cooled. So there was no air cooling, no liquid cooling. It was purely passive cooling concept. And let's say for German weather conditions, it worked out pretty well. So until the battery got hot, the battery was empty. So as simple as that. But of course, that's true for German weather conditions. For, let's say, tropical weather conditions, as we see in India, for sure that will have a big disadvantage. So you can keep the cost and complexity very low with the passive system. And that was actually what was driving us. So the fleet of EVs we had on public roads in 2010, 2011, and by honestly, we operated them for 8 years, so they really had a good lifetime. Was a focus on low cost and low complexity to fit also into a small vehicle. So I would say the concept worked very well, and we got evidence of 8 years endurance of testing on public roads. But again, I won't recommend this for tropical weather conditions as we see in India.
Hi, my question is to Srikanth sir. I think most of the firing problems happens due to that internal short circuiting and electrolyte breakdown. I think due to that only that gases are forming. As you mentioned, if we use that solid electrolyte, can that problem be avoided, like internal short circuiting or like the gas formation? Can it be avoided if you are using that solid electrolyte?
So the internal short circuit, when we say internal short circuit, this is internal to the cell. So the causes of internal short circuit are various. It is not limited to the electrolyte, like Thomas showed in his slides. The internal short circuit happens because of dendrites. That's one of the primary reasons. And dendrites can happen because of deep discharge or overcharge. The other reasons for internal short circuit is your manufacturing quality is bad. So you have a lot of impurities in your coating, you have a lot of bad coating, so empty spots or anything on your electrodes. So those are the causes of the short circuit. Now some of them can carry over to the solid electrolyte. The only thing here is there is no separator. The separation between the two electrodes is has much more tensile strength compared to the polymer separator in liquid electrolyte. So there are some advantages, but the major advantage of solid state electrolyte comes from the non-existence or we are not using the electrolytes that are used in the liquid electrolytes that we are using in the normal LFP cells, right? So those we can overcome. So those have the thermal stability less compared to the solid state electrolytes.
Then what could be the reason for the gas generation?
So the gas generation is the product of the side reactions that happen once there is a short circuit inside, once there is a dendrite formation.
Again, that also comes from the short circuit, right? When the side reaction.
Right. So that could happen from the short circuit. Yes. So we can discuss more offline. Yeah.
Thank you so much once again, Dr. Thomas Hulshorst and Dr. Srikanth Nagpure for sharing such a valuable information with all of us. So now I call upon I call upon my co-host to carry on with the other session. Thank you.
Thank you.
Proceeding further, now let us welcome Dr. Christian Saar, Vice President, Vehicle Development, FEV Group. He did his PhD degree with highest distinction at RWTH Aachen University in the area of lightweight design, and his areas of technical expertise are complete vehicle development, requirements engineering, and attribute engineering. He will enrich us on topic holistic thermal management for the electric vehicle.
Thanks a lot for the introduction. After the impressive presentation of Thomas Hilshorst, I would like now go from component or system level a little bit up to system and complete vehicle level. And what I'm going to present is the achievement of the worldwide thermal competence centers. Thank you. And I'm always impressed of the huge potential that's in the thermal system to achieve more efficiency of the complete vehicle, and with that to achieve more driving range, customer value, or bring down the cost if you don't want to enlarge the driving range. So there's a huge potential, and I'm always impressed of the achievements of the team. So I would like to present now the key drivers and our development process for achieving a complete, efficient thermal system in the vehicle. The key drivers, especially regarding BEVs, and our capabilities at FEV. I go into the development process, go then into the simulation and testing methodology, the complete vehicle, virtual vehicle, and the validation, the physical testing methodology. And last but not least, I go into some case studies and references just to show that it's not only a virtual world we are living in, but the achievements are in the real world customer value. Yeah, so I go into the key drivers. So regarding ICE and BEV, the differences, of course, electric vehicles have a significant less, I'll go to that one, significant less heat. Could I have that screen again, please? We do it like that. Okay. Test. It's not online. It's working? Okay, good. Okay, it's better like that. So the electric vehicle has significant less waste heat, of course, because of the missing combustion engine. So what we need now is, could you level it up? Level it up a little bit. Test. Is it better now? Okay, much better. Okay, thank you. So due to the missing internal combustion engine, we need now compensation for the missing waste heat. So we need electric power for the cabin climatization. The driving range will be reduced due to that. And of course, we have lower maximum temperatures for the component cooling available. And another very important thing, the battery temperature needs to be in a specific range. So we have a little bit different specifications we need to implement in the complete system. But the good thing in thermal management is that this methodology for the complete thermal system is pretty the same. So we do the same tools, we use the same tools, we use the same 1D system, and so it's just an erasure of some components and replacement of other components, but the methodology is the same. So we can offer both the BEV development and the IC and hybrid development. And I would like to go now through the development process of FEV. So what we do is the optimization of the complete vehicle system and, of course, of the components. Thomas Hülshorst just explained the development of the component and the impressive effects you can have in the components and the method how to prevent it. So that's part of our engineering work. We do implement ideas for the power reduction in the cabin climatization. And last but not least, as a result of all that, we deliver validated 1D simulation models and, of course, 3D simulation, a complete virtual vehicle, and including, of course, the validation, the real-world validation, for example, using wind tunnel testing. Last but not least, the vehicle homologation. We support our customers in that area and in the benchmarking. Where do we do that? Our thermal competence centers are located worldwide. So some in Europe. One is missing, a new one, where Hayri Ehren is located in Turkey. The other ones are in Aachen, Wolfsburg, Stuttgart, so German-wide, also in Poland, Krakow. Then in US, a huge center, and in Shanghai, and of course here in Pune. Wind tunnel partners, we have several in Europe, but also here in the Chinese market, so we have established connections to the wind tunnels where we can validate our systems. In total, we are more than 100 thermal engineers, some in the system area, many in the component areas. So in total, we can offer localized people directly located at the customers, and they have their network worldwide to implement all the competencies you need for the specific projects. I would like now to go into our methodology. What we normally do is using the 5-cycle test, well known, I would say, in the thermal area, driven by the US EPA, a test where you have 2 mandatory tests for highway and city cycles. It's more or less the same all over the world. And additionally, they have 3 optional tests. And this 5-cycle methodology is the basis for us for optimization of the complete vehicle system. Because there's a huge potential in the cold, hot, and aggressive cycles. And they are additionally to the mandatory tests. And what is now be done, it's not only that you optimize your vehicle and by using these 3 optional tests, it's also that the certification of your official driving range is done by this 5-cycle test. And we expect these 5 cycles to be handed over to the world. It's not only US, but it will also implement it in Europe, and it will also implement it in the Asian region. And for us, it's a basis for all optimization we are doing. And if you do it, it's not only that you have a very efficient vehicle as a customer value, it's also a marketing aspect, because the optional benefit you will get if you fulfill the 3 additional cycles will lead to an official higher driving range. So it's not only a more efficient car, but you can also officially state that your car has a higher driving range. And so that's the basis for our optimization strategy. And to make it a little bit more in detail, these 5 cycles here in the middle, we analyzed any different cycle, and for every market, every customer needs, we analyze which power demand is the one we would like to optimize to have the most effective impact for your complete system. For example, if you look to the upper left side, there's a cold cycle. The cold cycle is the one in Europe that has a huge potential because the energy losses and the consumer needs on the left side. 40% of that is related to the thermal system. So if you optimize the thermal system, you have a huge impact in the complete efficiency of your vehicle. And we do it for every single cycle and every single market, so we can point out which optimization strategy would be the best for you. And if you do, you will see at the official driving range that, for example, the Tesla Model Y is significantly 10% better than the other cars, because they fulfilled the 3 optional tests. So it is a very efficient car, but additionally, because it is an efficient car and it fulfills all these 3 optional tests, it's also officially better. So really a customer value and a marketing aspect for you, and you should really think about that to go with us into the deep analysis of your efficiency of every single component and the complete system. An example, what we then did, for every single project, there's a 1D model, an example on the left-hand side, where we integrated many components in one system, too many for a serious production car, but we introduced as many as possible to make the system as complex as possible, to show which potential is in every single component, and for every cycle and for every market, you can optimize your strategy. At the end, erase the components you do not want to have in your serial production car, and then have the best optimized car for that specific market and customer and region. In the middle area, you see some figures, and you will see the exact figures, 33% reduction in one of the last slides. There's a reference I will show, and a reference vehicle and reference project where I will come back to this 33%. So our development process, it's based on what I said. We try to combine as much components as possible in one system. So the main systems in the car, the powertrain, cooling, and the cabin climatization are combined in one system, and the thermal system control will combine all these component systems in one function strategy. We support, of course, from pre-development, from first investigations up to serial production, and do this with our own simulation models, normally based on MATLAB, but any other 1D simulation software is possible. And we follow for that the normal V model. You know it. Some other presentators just mentioned that. So of course we go from the requirement analysis to the concept design, the simulation 1D and 3D, implement it and go to the testing, and of course all these feedback loops are implemented so that we always from ideas from the testing or results from the testing will go back to the simulation and the concept design. These feedback loops you can see here in the lower area. With all this information, we build up a virtual vehicle, 1D and 3D, and all the information will fit into the control strategy of our development process. So from the requirements over the tomology optimization, we go into the detail and calibration, and in the end, it's a normal, following the normal V process. But most important is that the control strategy and the system development is going hand in hand. It's the same like Michael Hogue explained from CAD and CAE. It's here the controls and the systems. We are going from the component specification and the requirement specification at the same time, going to the 1D layout, and in that area we are also developing the EE architecture. Functional description will take part, and going then into the software implementation parallel to the hardware design and the 3D validation. and at the end, the component full vehicle testing will take place, and the system calibration. And for all of these four, there are four figures, for all of these four areas, I have one specific slide. So in the concept definition, we, of course, first make an analysis of the market, which market is the target market, which customer behavior is there, what's the cost framework we are dealing with. The environmental conditions are really important. So like we see here, it's a hot weather country. With regards to Europe, you have totally different requirements. So we analyze that with the customer together. We define the requirements and the functions that are needed. Go then into the 1D thermal systems model. Complete model could be a very easy one, could be a really complex one based on our methodology that we have a base 1D model, very complex, and we erase everything that's not needed and have then the 1D model. Parallel to that, we go into the supplier management, so the selection of the components. And with our network, we have more or less a list of suppliers, possible suppliers for every component we could introduce into the project. The second step would then go more into the function. So we need to define which function is important for the customer, which component is needed for that. So do we have a heat pump integration or not? In our proposal, always heat pump will be taken into consideration because there's a huge potential. Active grill shutter, especially for BEVs thing, where you could really achieve some arrow points. Battery cooling, of course, we heard about it. Powertrain cooling or motor cooling in this case for EVs. Efficiency, one of the major tasks we will then do, the combination of the different components fit together like a puzzle, so that not every single component has to be layout, worst case layout. So the fitting together of different components lead to a more efficient total system. Cabin comfort, of course, one of the major points where you are able to achieve efficiency. Third point is then the simulation methodology, the 3D. Michael Hoke showed some pictures about that. I would like to highlight a little bit more the air vents, defrost and defog. Huge knowledge base available at us for these points. Very important, especially in different markets. Cold but also warm areas, very, very important. The air vents underflow, Michael Hoke just explained, but also the underhood, very important. And of course, as he also explained, the complete vehicle aero, very important because the thermal system is very dependent on the airflow or inflow through the grill, and we always consider a grill shutter could be beneficial, must not be, depends on the layout of the system. Last but not least, the fourth point, we are going into the physical validation. So of course we have all measurement instrumentation available at FEV, so we can implement anything you need for proper validation of the vehicle. We do the planning, complete vehicle planning, the complete worldwide coordination of tests in climatic wind tunnels, on test tracks, on the public road testing. So whatever is needed, we can do. And due to the network of FEV, we have connections into every single country of the world. where we do our hot and cold country testing, have the connections to the test drivers, so we can perform huge programs for durability testing, for thermal validation testing. At the end, of course, the evaluation of the test results and doing the feedback loop into the simulation and optimization of the complete system. And I would like now to go into some case studies where we proved the optimization potential of the system. Here you can see the system I explained in the beginning. It's a very complex system. We did for a tier 1 supplier, where we proved that with different components, introducing heat pumps and introducing optimized control strategies, we reduced in cold conditions a reduction of 33% in the complete system. At first, we measured a reference car, simulated our reference model, and then played around with all these different components and a combination of components and have a simulation result. We did that for different conditions and even for warm conditions, even in hot condition countries. We have a potential of 17% when we change from PTC to heat pump for climatization of the interior and other optimization of the strategy. The effect, of course, is either you increase the driving range or you decrease the size of the battery and have the cost effect for the customer. Another really interesting point, a case study for surface heating. Not to say that it's also a PhD thesis of Eren Hayri. It's another project he did, but the knowledge in the company is really there. We did, in this case, we did the replacement of the heating, the cabin heating, by surface heating. Here we did it in the lower area, in the food area, following the simple principle warm feet and cold head. And we reduced, only by that, we reduced the energy demand of the complete system by 16%. So huge potential. This effect was at minus 20 degrees, so when you really need heating. Hayri showed in his PhD the potential was even higher if you apply that system into buses. So buses where you have more surfaces, more package freedom, where you can introduce these surfaces even in higher areas above your head. So he proved a potential of up to 30%. So huge potential. Of course, that's a potential you can reach at minus 20 degrees. We did a sensitivity analysis. Of course, when you don't need heating, there's no potential. But in average, in European market, there's an annual average of 7%. So you look at the average temperatures on the European market, and you see that only with replacement of those components, you have a potential of 7% of the complete energy demand of the vehicle. So huge potential. And what you can, of course, do, you can offer for your customer increased driving range, or you can reduce the battery size and the cost. If you use it for buses, you would reduce the battery size because the driving range is fixed. So you can decrease the cost significantly. So really a very, very high potential component to introduce into interior climatization. Last but not least, some references. We did use that methodology, that 1D model and all I explained for a medium-duty BEV, so a European OEM for a medium delivery vehicle. We did the complete thermal system development, the complete requirement definition, the specification of the components, did the supplier selection, and did the complete virtual vehicle, so the thermal system simulation in 1D and 3D, and of course the function development and specification. At the end, the thermal validation at test benches at FEV and also on test tracks. Another reference, that's the implementation of the methodology I showed for a tier 1, Asian tier 1 supplier. So we implemented that methodology and that simulation, that virtual vehicle, into a demo vehicle. So that supplier has now a demo vehicle that's exactly parallel to the virtual vehicle, to the complex system of the virtual vehicle, where we have any possible component that could be in a vehicle, so very complex, too complex. And he can now play around in the simulation world with different components, with different strategies, different temperature levels, different flow rates, and so on, and optimize the system. And at the end, he can validate it with his demo vehicle, because they are pretty the same. And he can then show up for customers, for anyone, the potential of the optimization of the complete system. So really impressive, that project. One project we want to present was a complete vehicle development for an Asian OEM, where we, of course, as a complete vehicle developer, also developed the thermal system. We were completely responsible for any thermal tasks. It's a component, of course, because of the component development, but also for the complete system. And my team did then the thermal management tasks like architecture definition, the function definition, interface definition, component selection. And it was a pretty complex system with a heat pump, with an active grill shutter, with weight heat recovery, and two-zone climatization. So pretty complex system, and yeah, pretty impressive what the team did with that kind of efficiency. And last but not least, one reference for heavy-duty area. Some presentations ago, we heard about the potential of fuel cells that have more potential in the heavy-duty area. Here's a reference exactly for that. We did a task force for a heavy-duty OEM where he had some thermal issues, and we stepped into the project. We got the understanding of the fuel cell derating criteria, mechanisms, created mitigation strategies, and quantified the additional cooling demand, and implemented an additional cooling system into the complete system, integrated in the cooling strategies, thermal strategy. And yeah, at the end, the existing vehicle could be updated with an additional system to fulfill the thermal demands. So that was my last slide. I tried to show you the huge potential of thermal management, huge potential for driving range, customer value, and we would really be happy to be in contact with you to identify the potential, develop new systems, optimize the existing systems. And yeah, we are here. We are open for discussions and now open for questions.
Thank you, Dr. Christian Sir, for sharing your thoughts with us. How splendidly, one after another, our speakers guided us through all the various facets of automobile technology in convenient yet inspiring way. Each of us present here today had a sneak peek of how revolutionary this vehicle technology is. As FEVians, with our vision and values ingrained in our DNA, anticipate putting together such events in future. Now, I would like to invite Mr. Sushil Berry, Director of FEV India, with a demonstrated history of working in automotive industry. He has been associated with FEV India since the beginning and was serving as a managing director till 2019, and request him to offer a vote of thanks.
So, good evening, ladies and gentlemen. Wow, what a day of the information and technology flow. It was awesome. I noticed one thing today. It was raining outside, but the real thunder showers of technology were raining inside this room. So, coming back to the vote of thanks, so I have been entrusted with this, and we have to do this. This is tradition of every tech day. So I would like to thank, first of all, our chief guest, Mr. Petkar, for sharing his views through his keynote speech on technology, innovation, global challenges, economies, behavior during the COVID situation and also the war situation. Thank you, Mr. Petkar. Then the journey went on to Alex Naze. Alex, it's always a treat to listen to you. You shared your complete, complex views on all the automotive trends and the future technologies. This was very, very informative. Then Bernd Kircher, thank you very much for sharing information on the technologies, how to reduce weights in the BEVs, and fusion technologies, the lightweight technologies. I think this was also quite informative. Mr. Hogg, the vehicle hero, always gives very lengthy presentations, very informative. Yes, thank you very much. The flow of the body in white development, a deep dive into electric vehicles development was quite informative. Dietrich Thoss and Sachin Wagh. Wow, what a dynamic presentation. I thought it was some award ceremony. You guys were so dynamic, and your presentation was so dynamic, really. It charged me so much after listening to your presentation, how to convert an ICE to BEV. I thought the first thing I will do in Delhi is I'll convert one of my ICE vehicles. Yeah? You made it so simple, but reality is, yes, it's complex, it's tough, it's not that easy. So second innings of Michael Hogg, where along with Ashraf, and you people presented a case of Egyptian BEV and the colleagues from Egypt. I think this information was quite good. And then, oh my goodness, a pool of information, Anand Bhange. Oh, what you did, man. Software-defined vehicles, you said these are 3 words and so easy to pronounce. And when you started the journey, I tell you, it was so complex, but it was wonderful how you took us through the by-lanes of this software technology. Really, really very informative. And I'm pretty sure that in this hall, you have only touched the tip of the iceberg. Yeah? It shows how deep knowledge you have and how it is immensely going to help all our clients. So please make full use of this man. Dr. Hulsost, again another gentleman. It's always a pleasure to listen to him. He sometimes I think he's a kind of a human dictionary, you know, on the electric vehicles. Anything related to electric vehicles, you ask him a question and he has an answer. So really wonderful. And of course, our homegrown Dr. Shrikant, you were also amazing. Thank you. You all spoke about the technologies of LFP and NMC. I think a lot of information flow was there as well. And then coming towards the end, we Had the pleasure of listening to Dr. Christian. Thank you very much. Your information on this thermal management of EVs, I think it was also quite informative, and people will approach you maybe with a lot of questions afterwards. A very big thank you to the lovely ladies who handled the show very well, kept audience alive with their quiz. Of course, I was the first winner, but that was cheating. So sorry for that. Okay, last but not least, also a big thanks to all FEVians for making this event successful with their hard work and enthusiasm. Let's all give them a big round of applause. So once again, ladies and gentlemen, you have been a great audience. Thank you for coming. Thank you for listening to us, and we appreciate this very much. Please feel free to ask any questions at any stage to FEV. FEV is a very, very open company. We always love to share information with our clients because we say sharing is caring, and first you need to have the friendship, business comes later. Yeah? So first win the trust of the client. So thank you.
Thank you, Mr. Sushil Berry, for kind words. It adds value to our vision and our aspiration. As the session comes to an end, we FEVians are extremely grateful and make a heartfelt commitment to continue working towards achieving our goal of building global partnership to develop sustainable energy and mobility solutions. On behalf of entire FEV family, I would like to thank you all for taking time out from your busy schedules and attending this event. Thank you, everyone. Have a great evening ahead.
Excuse me, I'll request everyone to please have a cup of tea, coffee in the dining area before you leave.